Hello, everyone. Thank you very much for coming today to today's AIAA Los Angeles Las Vegas sections e-town hall meeting. We have two fantastic speakers and on very fascinating topics. Um, please stay with us and enjoy the event. Okay, so this is tentative. This is our agenda today. So we are doing the introduction right now, and the in a few minutes, Mr. Jim Payne will start his legendary talk on the glider, Perlan glider, and around 10:45. It's a little bit flexible, so don't try to be very tight. So we have Lieutenant Colonel Mark Hasara talking about very exciting, time-critical air refueling, missions. Very exciting stories. So, as you know, AIAA is a nonprofit 501c3 organization promoting aerospace. It's membership based. We have tons of professionals, student educators, professors, and enthusiasts. So we do have different type of membership, and we have a new so-called e-membership. Is give you a 1 year free trial before you decide to join the professional membership. And we welcome volunteers and if you are interested, please contact me or contact our section chair with the email here. You can see in the middle at Gmail. And we post our events in several places. You can join our mailing list. You can receive the notice right away, or it's posted on the link there, aiaa-llv.org/events. The membership information you can look at aiaa.org/membership. And the Zoom, if you are concerned about the security, you can try to dial in, but Zoom has improved a lot from the very beginning. So it should be, so rest assured, if any problem, just keep connecting and it should be okay. And during the presentation, especially the first one, please type your question in Q&A and or chat box. During the Q&A, the question and answer session at the end, you are welcome to raise your hand and you will be able to speak out. But during the presentation, please don't interrupt. But you are welcome to type your question in text, in chat or Q&A box. Okay, so just a few words about Southern California. So we are really blessed. We have so many aerospace activities here. So we have like Northrop Grumman doing the space telescope, building spacecraft, satellites, and also defense, building the, fighter jet, bomber, advanced aircraft like a EA-18G Growler, which we have a presentation 2 weeks from today, from talking about this the missions. And we have JPL, we have Mars Insight, also Mars 2020, Perseverance. And we have many companies here, Aerospace Corporation, SpaceX, Global Aerospace. They are doing the space debris mitigation, and there were people expert here doing planetary defense, astro exploration. Then we have Virgin Galactic, Virgin Orbit, and also SpaceX. Those exciting new space companies, and then we have very exciting student branches doing student either rocket launch or design, build, and fly AIAA projects. And all those great things won't happen because our dedication of our AIAA officers and with the leadership from our advisors like Dr. Jeffrey Purcell from Raytheon, he's our AIAA fellow, and Marsha Weisskopf from Aerospace Corporation, and Bob Friend, a director from Boeing Defense, Space and Security, and all other dedicated members, officers. So it's amazing. And Maryland. Okay, so once you join AIAA, you can immediately log in and have engaged chat with fellow AIAA members globally. So it's like a social media, so it's very exciting. Immediately connect, engage with AIAA. So we regularly have events, to keep people informed and engaged. And these are actually meant for networking. So you are welcome to chat, and know some friends, old friends. But the topic itself is just to keep people interested in aerospace. So more information. So we just have ISS 20 years anniversary last week with folks from Aerojet Rocketdyne and very exciting, gadget inventor. So this is just to show you that AIAA is a very good professional society. It's very reputable, based in Reston, Virginia. It was merged in, I think, 1950s, 60s from two distinguished organizations, one founded by Wright brothers, the other founded by Robert Goddard. And so you got a lot of resources, publication. We publish, we also do research and outreach education. So it's a great benefit to join AIAA. Different levels of educator membership is free. Student, $25 per year, and e-membership child-free first year. So there's some contact if you want to know more about it, or you can chat and I will try to answer or direct to the right person. Okay, so the first speaker today, Mr. Jim Payne, is really doing very exciting project. It's like a legendary, in this the field he's been doing. He was a chief pilot and board member of the Perlan project. He was a test pilot instructor, the U.S. Air Force Academy. Retired from there. He was a consultant with NASA. He was a manager of Northrop's Global Hawk program. He's a test pilot also for Northrop's Firebird program. Test pilot of the year, Kishiro Award, Society of Experimental Test Pilot. 2019 Guinness Book of Records Aviation page, Inspiration and the Patriotism Award, Living Legends of Aviation. In 2018. Typically, we don't go through too much, but because this is a very unique opportunity, so I'm pretty sure you also read it online. But we just try to learn a little more. Mr. Payne started soaring at the Air Force Academy in 1971. At the Academy, he made his first wave flight and was immediately hooked. His paper for his senior technical writing course was a report on high altitude sailplane flight. He graduated outstanding cadet in soaring in 1974. He flew F-4, F-5, F-16, F-16XL, among other aircraft for the Air Force. He was the first pilot selected to pioneer the Air Force Institute Technology Masters with a follow-on assignment to Air Force Test Pilot School. He returned down a full ride to Stanford since it was not coupled with TPS. In 1983, Jim earned his gold and diamond altitude legs in SGS 1-26 in the Tehachapi wave. When he was assigned to the staff at the U.S. Air Force Test Pilot School, he was part of the Soar Eagle project. The team equipped a Grob 103 with a pressure suit program. Soaring in his sailplane, Jim earned a triple landing pin or a flight to 42,200 feet with the advent of GPS flight recorders. Jim pioneered wave speed records. He taught flight tests at the United States Air Force Academy. When he could not find a good textbook to use, he wrote his own. He instilled a love of flying and the leadership in the next generation of Air Force commanders. Jim coached the U.S. Air Force Academy cross-country soaring team through several camps and contests. Jim managed the U.S. international soaring team for 5 world championships. He was the open class pilot in the South Africa World Champions in 2001. After Jim retired from Air Force, he consulted for NASA and then managed Northrop's Global Hawk multi-million-dollar program for 10 years. He moved to Northrop's Firebird program and flew first flight before retiring again. He now works full-time volunteering as chief pilot for Perlan project, where he developed and led the test program. For many years, he held the fastest world record at 247 km per hour, 154 mile per hour, a record that was listed in 2006 Guinness record. In recent years, Jim has used the wave to win numerous OLC championships. World champion in the OLC Classic 6 times and a world champion in OLC Speed 8 times. Jim was awarded the 2001 Lidenthal Medal winner, highest award given by the FAI for gliding, and is a member of the Soaring Hall of Fame. He has set 70 world soaring records and over 95 national records. Jim and his brother Tom were national open play soaring champions. Jim won the Baron Hilton Cup and the Return to Kitty Hawk race across America in 2003. He was awarded the Soaring Society of America's highest honor, the Eaton Trophy, in 2003. One of his records has been chosen as the most memorable record and precedented 9 different years by the National Aeronautic Association. He flew the Challenger Perlan 2 from first flight in 2015 through the world record-setting high-altitude flights in Argentina in 2018. So this is truly legendary. So let's welcome, Mr. Jim Payne.
Well, thank you, Ken.
Great pleasure.
Okay, Ken, can you see the screen?
Yes. Yes.
Okay, well, good morning. It's my pleasure to talk about the Perlan 2 sailplane and the flying that we have done. It's been a pretty amazing project, and it's been a lot of fun along the way and a lot of work. The goals of the Perlan project, which is actually a 5013C organization, is to innovate, explore, and inspire. There's been a lot of neat innovations into the Perlan 2 sailplane itself. The stratospheric wave that we fly in that's new exploration. And then we want to inspire future people to become engineers and be interested in aerospace. And kind of our goal here is we've exceeded the highest official altitude flown by the U-2, and the only other airplane that's flown winged flight higher than the U-2 is SR-71, and we're trying to do that with the Perlan. So the background here, I'll talk a little bit about how I got here. I'm sure there's some students out there that hopefully can be inspired by an example. Talk about the big mountain waves we used to fly high, the construction and some of the engineering that went into the Perlan 2. To go to Argentina and fly these high flights is a logistical nightmare, so to speak. Talk a little bit about how we've overcome the obstacles. And a little bit about Argentina. Southern Argentina, Patagonia is a fantastic place to visit. And if you've never been there, it's worth putting on your bucket list. And then the heart of the story here is flying the Perlan 2. I'll talk about 2 different flights. One that we did to 52,000 feet, which is our first record. And then the final flight to flight level 760. As Ken mentioned, when I was at the Air Force Academy, I became interested in high altitude sailplane flight, and I did write my final paper for my technical writing course on how to fly to high altitude. And that was done back in 1973, a long time ago. So for those of you with a dream, never give up. Soaring itself occurred when I was an instructor at test pilot school in the 1980s. And what we did was we borrowed all kinds of parts from around Edwards. We had a liquid oxygen system from an F-16. We had the heat exchanger from I was part of the liquid oxygen system from the F-16, but we had a F4 term needle. We had the emergency bailout backpack from an X-15 that was left over. The spacesuit came from the SR-71 project and so on. We incorporated it into Grove 103. And I was able to fly that several times and managed to get to flight level 42.2 and got a triple any pin. As part of these flights, we noted that the mountain wave in the temperate latitudes tended to be capped at the tropopause. And the primary reason is in the moderate latitudes at the tropopause, the wind speeds tend to die off. And in order to propagate the wave to high altitude, you need to have a wind flow, which is essentially constant energy, which means that the true speed of the wind has to increase as you go up in altitude. So for a long time, we in the soaring community figured that tropopause was kind of the maximum. It was on this particular day. The North American record at this time was about 49,000 feet. And that was done on a day when the Vandenberg sounding showed the triple pauses well above 50,000 feet. So as Ken mentioned, I've had a lot of fun over the years. And I've been able to claim a bunch of past records, high records, and long records. Now, flying sailplanes at high altitude or long distances requires micrometeorology that a lot of people don't even know exists. And as such, I think pilots are some of the best meteorologists in the world because meteorology impacts their flying. In particular, mountain waves, if I can get a pointer to work here, occur when we have strong wind flying close to perpendicular from a mountain range and stable air. As the stable air comes over the mountain range, it tends to sink on the downwind side and then it rebounds. And you get this three-dimensional wave, which is for the most part invisible. On the perfect days, you get a few clouds, which we call lenticulars, which mark the peaks of the wave. And at low altitude, we have a zone, which we call the rotor, which can have some clouds in it. And this zone has some of the most severe turbulence you can imagine. Flying out of some place like Cal City, which is downwind of the mountain wave, requires you to tow through the rotor. And it's kind of like being inside of a washing machine with severe turbulence. And then when you get into the lifting zone and the wave itself, it's some of the most laminar air you can imagine. And the transition occurs in a very short distance, approximately the length of a tow rope, about 200 feet. So flying out of Cal City, you're in this severe turbulence. All of a sudden, the tow plane stops dancing and suddenly rises. And a couple seconds later, the same thing happens to you in the sailplane. And typically we stay on just a little bit to make sure that we're clear of the rotor, get off tow. And then we just do zigzags back and forth as we climb here in the zone that's lifting. On the right here is an example of some of the clouds. So down low, we have some clouds which are formed by the rotor. And up aloft, we see some of the lenticular clouds, the lens-shaped clouds, which are a result of the mountain wave. Now, Einar Volson, who had spent a lot of time at Edwards, he worked at then NASA Dryden, now NASA Armstrong for many years, retired from NASA and was working in Germany. And he was walking down the hall at Grobe Aircraft where he was working, and the meteorologist that worked for the company had posted this image somewhere on his wall. And Einar saw it, and it piqued his interest. And basically, this is a LiDAR image that was taken by a modified aircraft that flew from, I guess they flew all the way from Finland to Iceland. And as they crossed over Sweden, downwind of the mountain range between Sweden and Norway, they took this LiDAR image. 23 kilometers is roughly 75,000 feet. And what it shows, in this case, the winds are coming from the left, a mountain wave, and the altitude. And this piqued Einar's interest because he was aware of our assumption that the mountain wave was capped at the tropopause. So he did a bunch of research and discovered that in the polar regions, there is something called polar night jet, or more commonly a polar vortex that occurs in the wintertime at the pole. In the case of Argentina, in the wintertime, they have westerlies, which are impinging on southern part Patagonia, easterlies coming across Brazil. That's why northern Argentina and Brazil are tropical, because the Andes take all of the moisture out and cause a tropical rainforest. But here in the southern part, if you look at the upper atmosphere, we get the circulation at very high altitude that goes around the pole. And El Calafate, Argentina, which is where the cross is far enough south to be underneath that effect. Here's another graphic of what happens. Basically, when the pole is in its night, of course, which lasts 6 months at the pole, and it gets extremely cold, air starts flowing towards the north, and because of Coriolis, you get this circulation. So Ainer did a lot of research. He got connected with Steve Fawcett. They got a Grobe, a 505 sailplane, and on August 29th, using pressure suits that they borrowed from NASA, they were able to fly to almost 51,000 feet to claim a new altitude record for sailplanes. Now, during that flight, they got extremely cold. In a normal sailplane, no matter how well you seal the canopy, it's going to leak around the canopy. So the temperature inside the cabin is not much warmer than the temperature on the outside, which at flight level 500 is rather cold. Also, pressure suits above 35,000 feet start getting stiff. They basically maintain the same pressure as at 35,000 feet. So by the time you get to 50,000 feet, the suit is pretty stiff, and it's very difficult to, say, adjust the avionics. And as such, on the way down, they decided that they would try to build a pressurized sailplane. And this is the genesis for the Perlan 2. Initially, they considered that they would like to have the capability to go to 100,000 feet, but the practical limit for wingspan is about 25 meters. That's typical of an open class sailplane. Steve wanted it to be a two-seater, and he also wanted it to be a shirt sleeve environment, i.e. no pressure suits. So that really kind of drove the design of the Perlan 2. Aerodynamics are optimized for climb. In the sailplane, when you're trying to climb, of course, you're going to be flying at your minimum sink speed, which in the case of the Perlan is, it's a function of weight and mass, but it's around 46 to 47 knots indicated airspeed. Thus, we ended up with a fixed main wheel. At the low airspeed, retracting the wheel does not provide that much decrease in drag. And because it's pressurized, we had to have an aft cabin bulkhead, which would be in the area where the wheel would go if it's retractable. So ended up with a fixed gear. If you do a study of the expected climb rates in the mountain wave based on models, the minimum climb rate is probably going to be around flight level 600. Also, if you have an airfoil which is optimized for Reynolds numbers that occur at low altitude, by the time you get much above 50,000 feet, the Reynolds number is so far off that you start having flow separations and stuff that are non-optimum and cause lots of drag. So the airfoil was optimized for flight level 600, which means, of course, we sacrifice a little bit of performance at lower altitudes, but as you get higher, the sailplane is much more efficient. And the true airspeed is very high at high altitude. So you have to have a structure that is designed to have an extremely high flutter speed limit. So here's a graph that kind of shows our challenge. Stall speeds 38 knots. You two guys say it might increase a couple knots as you go to altitude due to Reynolds numbers effects. The VNE at flight level 900 is 54 knots indicated. So if you extrapolate these two up a little bit, they actually coincide at flight level 960. But in order to do our zigzags in the wave to stay in the lifting zone, we need to be able to turn. So that makes the practical limit for the Perlan 2 flight level 900. At flight level 900, the true airspeed is 6.7 times the indicated airspeed on a standard day. So if you're flying at stall speed, your true airspeed is going to be somewhere on the order of 275 knots true airspeed. And if you go out to 54 knots indicated airspeed, your true airspeed is on the order of 380 knots. So you're actually flying pretty fast at high altitude. On the other hand, the wind speed at high altitude on a good day might be 200 knots. So between the two effects, it's actually a situation where you're able to climb. Structures, it was designed for slightly higher G load than you might design for a normal category airplane. Just because there's some uncertainty about turbulence at high altitude, it's possible that you might encounter some strong turbulence in what is known as a breaking wave. Knock on wood, we have not encountered that with Perlan 2, but it's a possibility given fluid dynamics. The structure needs to be flutter-free in the flight envelope. And because Steve wanted the airplane to be shirt sleeve, for the pressurization system, we use a safety factor of 3, which is the standard practice for spacecraft. And typically in your airplane, the safety factor is 1.5 when you're designing things like the spar and so on. So for instance, the airplane is designed for a maximum pressure or pressure differential of 8.5 PSI. And we actually built a test fuselage, which we pressurized at 25 PSI to prove that it had a safety factor of 3. And actually at 25 PSI, the aft bulkhead cracked as designed so that we wouldn't have a massive structural failure if it did get over pressurized. So the Perlan 2 can be best described as a space capsule with wings. The crew sets fore and aft in tandem. The wingspan is 84 feet, like 25.6 meters. The maximum flying weight is 2,000 pounds. It's highly instrumented. We have 22 Arduinos on it that comprise the instrumentation system. And those are located on various pieces of hardware that are critical. We did discover that a lot of things don't work very well when they're cold. And we ended up putting a heater on the battery, for instance. We have heaters on the air bottle and O2 bottle regulators, so those don't fail. We have flutter exciters in the wing. Those even needed heaters. Put on nav and strobe lights, so I had the option of landing after sunset. It has a ballistic recovery system. It's a chute that's designed to lower the whole airplane. And that was done because the way we enter and exit from the cockpit are through these round hatches on the top of the cabin. And it would be probably impossible to get out of the cabin with a backpack parachute on if the aircraft was doing some sort of gyration, such as an uncontrolled spin. So I had the BRS. Now, there's a possibility of upset at high altitude, and you really don't want to use the BRS at high true airspeeds. So in the tail, we have a drogue chute, which is designed to be speed limiting. The airplane can basically come straight down at 80 knots indicated airspeed. This is to allow for rapid emergency descents in case the cabin develops a leak, for instance. And of course, it could help recover from some sort of upset at high altitude. The drogue chute is jettisonable, whereas the BRS is not. We do have a science bay aft of the second cockpit. And in there, we're able to carry CubeSats and other science payloads. And one thing we did that really turned out to be a wise decision for us was we have a camera on the top of the tail. In fact, right now we're flying with 2 cameras. One is a Verb 360, so we can actually, while we're flying, look underneath us, look behind us, so we can look at the clouds and check the weather around us. And there's also a forward-looking camera, which provides excellent video for us. We also have a camera in the front of, excuse me, the fairing for the main wheel. And that also provides some interesting perspectives. For the pressurization system, basically the cabin is sealed, so we got a very low leak rate. And as any air leaks out, we add air from a scuba tank being located in the fuselage boom. The whole system is designed to last for 8 hours. We're using scuba air because we wanted an environment which had 21% oxygen. The cabin is lightly pressurized. If the oxygen system fails, we still have enough pressure in the cabin that we can take our mask off and not conk out shortly. But basically up to 16,500 feet, we have about half a PSI overpressure that helps hold the hatch in. And then above 16,500 feet, we keep the cabin pressure at the equivalent of 16,500 feet. Maximum differential being 8.5. We have an oxygen rebreather system. The desired maximum cabin oxygen concentration is 26%. If you use a normal oxygen system, it actually wastes a lot of oxygen. As you breathe, you're off-gassing quite a bit of oxygen, whereas in the rebreather, because it's a closed loop system, the only oxygen you use is what you metabolize. So as such, this is an extremely efficient system. In the loop, we have 100% oxygen, and then there's a carbon dioxide scrubber. So it's actually a really simple system. Basically, when you exhale, the air goes through the scrubber, and then it goes into this counter lung. If you didn't have the counter lung, when you inhaled or exhaled, you would feel a huge pressure difference. So this has a bladder in here, which goes opposite your breathing, so that you have a constant pressure in the loop. Loop has like a half a PSI, half an inch of water overpressure. So if there's any leaks, it's going to leak outward as opposed to getting just nitrogen into the system. And this has been a huge success for us. It's worked very well. Our drug chute at 15-foot diameter allows us to go 80 knots straight down. We actually did an in-flight deployment to verify that it worked. And this is a picture from that. And the BRS, this is just a graphic from the BRS people. They convinced us to have the glider descend very nose low. And the reason for that is, given the wingspan and wing loading, if you had the glider coming down flat, they say it would oscillate very badly. And you can't count on its position upon landing. As the night test program, there's a lot of ground testing to prove that you did it right. So the wings have been proof loaded, and of course they're rather flexible. So we had to build the structure to keep the wingtips off the floor when they're fully loaded. And because we're concerned about flutter at the very high altitude, ATA in San Diego did a ground vibration test for us. And they were kind of excited about this because normally they travel to the vendor. In this case, we brought the glider to them, and their lab wasn't quite big enough. They had to have one wing stick out the door, but they put accelerometers all around the sailplane and did their ground vibration. And from the ground vibration, we created a flutter model, and the model says that we got a flutter-free flight envelope. But most of our flight testing has involved flutter testing so that we can prove that the model is correct. The flight flutter testing, one of the key components is a system which our chief engineer built, Morgan Sandercock. And basically, he has these weights that are driven by stepper motors that are installed in the wing spar stub for the wingtip. And we can control these from the cockpit, and he can swing these weights between 2 and 30 hertz to excite the wingtips. And in the cockpit, while we are exciting the bending and twisting, we have this display which shows the response of the airplane. And you can see in this case right here, around 5 hertz, we're getting a little response in the twisting, and in the bending, we're getting a little response around 10 hertz as we go out towards 30 hertz. Of course, if any of these exceeds our design goal, they turn red. We've never seen that happen, but we can switch the system off in the cabin. Now, our telemetry does not have enough bandwidth for us to send the data real time to the ground. So while we're actually running the flight excitation, we in the cockpit are monitoring it. At the end of our 20-second run, then we telemeter the data file to the ground, which takes about 5 minutes. And the folks on the ground then, if we're in Argentina, email the file to ATA in San Diego, who run an analysis for us. So it takes us about 15 minutes to clear a flutter point, i.e. to collect the data, send it to the ground, get it to ATA, and for them to run it through their program to make sure that the result is matching what has been predicted by the flutter programs. Okay, so flying the Perlan 2 and exploring the stratosphere. First flight was done in 2015 in Redmond, Oregon, where the airplane was assembled, and that was an uneventful flight. To date, we have had 4 campaigns in Argentina. The 2020 campaign was unfortunately canceled because of the COVID thing. Basically, it's impossible to fly to Argentina right now, so that ruined 2020, but we've had some excellent campaigns. Getting the Perlan 2 and our equipment to Argentina is a logistical challenge. The sailplane was actually designed so it fit in a trailer that would fit inside a 40-foot container. So as such, to get the wingspan that we have, the wingtips had to be removable. And the outer 2 meters of the wingtips on each side come off and are separate. The folks at Cobra built us this custom trailer. And we actually end up taking the tongue off of the trailer to get it to fit into the container. Now in Argentina, because of their customs situation and their trade deficit, it's almost impossible to import stuff. So when we go to Argentina, we sit down and have this large list of potential spares that we might need. And we pack those around the sides of the container and all of our ground logistical equipment. So once we get everything packed in a container, it goes on a truck. The truck takes it to the Los Angeles area, and the Port of Los Angeles or Port of Long Beach, depending on the carrier, is where it starts. It's a voyage. And then it goes on a container ship, and each trip it seems to go to a different port, but it'll stop somewhere normally in Mexico and may trade ships. Then it goes down and either stops in Colombia or Ecuador. It ends up going down to Valparaiso, Chile normally, which is a port just across from Santiago. And this whole voyage normally takes 3 weeks or so. Then once it gets to Chile, it has to go to Argentina. Now, Argentina in Mendoza have what they call a dry dock. So the container is sealed, it goes to Mendoza, and that's where we do customs. Unfortunately, when we shipped the glider to Argentina for our high altitude flights, it's wintertime. There's a tunnel at the peak of the Andes, but to get to the tunnel and stuff, sometimes there's delays due to snow on the road. And then Argentina, they do have a road that goes along the Andes, Route to 40, but in places it's dirt. So the truckers always take it off towards the East Coast and a long way down to El Calafate in the southern part so that they're on paved roads and don't damage everything through vibrations. So the container arrives at El Calafate, another 10,000 miles away. And we open up the container and immediately open up the trailer so they can assemble the glider. And actually after one trip, the very first trip, there was damage. The trailer had actually been taken out of the container by someone, we think in Mexican customs, and they didn't put it back in the container securely. So it got one of the wings got a little bit of damage. So El Calafate, where we fly, is now a tourist town. 15 years ago, it was a really, really small village. Now it's a little bit bigger, and they have this airport, 150-foot wide runway by almost 8,000 feet. The Aero Club has a nice little hangar here that the Perlan fits in. So we normally keep the Perlan there, and when we do flight ops, we tow it out and have to back taxi to get on the runway for takeoff. You'll note that all the rubber's on the east end of the runway, and that's because 99% of the time the winds are out of the west of El Calafate. So this is Lago Argentino, and this is the Andes at the southern end. The highest peaks in here are off to the right a little bit, and they're roughly 11,000 feet. Most of these peaks here are 9,000 to 10,000 feet. The airport's about 700 feet, and typically we just take off and we tow towards the Andes. The wave is downwind of the ridge here, so it's almost a 30-mile tow to get to the lifting zones. But for our operations, this is a fantastic facility and location. And the town is here. As I mentioned, it's now a tourist town. So until COVID, they had lots of nice restaurants and hotels and stuff. The town's been closed for the last 9 months. So I hope everybody survives there. In this area, the Andes have lots of glaciers. There's a big glacier national park, which extends, I don't know, for about 100 miles or so here, maybe 200 miles. Again, El Calafate is here along Lago Argentino, and then we take off and we do our flying parallel to the Andes along the border with Chile. There's some things worth visiting. Pedro Moreno Glacier, which is the glacier directly to the west of El Calafate, is a pretty big glacier, 19 miles long, 3 miles across. The face of the glacier rises a couple hundred feet above the water. And it's kind of interesting in it that it crosses the valley and forms a dam. As you can see in this picture, the glacier is essentially all the way across the valley, and it basically dams up this arm of the lake. So this side of the lake gets 70 feet or so higher than this side of the lake. And in fact, you can kind of see where the water line has been higher than it was when we took this picture. And when it gets to about 70 feet, there's enough pressure that it'll breach the glacier. It'll actually erode the glacier. And then they have a little mini tsunami as the water levels level out and the water goes into the main part of the lake. And if you look online, you can actually find movies of this happening. But again, the glacier's moving this way. This little face right here is about 200 feet high. This is a picture taken from the tourist platform. And my wife visited this one day several years ago, and she saw this little crack here, and she goes, "You know what? That's gonna fall." And a day later, and got this video. So she just happened to be there at the right time. Now this is 200 feet high, so this piece of rock or ice that fell off is going to be much larger than a house. It's pretty amazing. The glacier moves about 2,100 feet a year, so roughly 7 feet a day or so, the face advances. And if you take a boat ride around the area, there's lots of other glaciers to see and icebergs, and you see interesting things like these holes in this iceberg. Mount Fitzroy, or El Chaten, is basically 11,000 feet, and it is 60 miles north of El Calafate or so. If you look at the shape here, the Patagonia clothing line, this is the symbol that they use, but this is Mount Fitzroy. And then this peak right here is Cerro Torre, which is a tower. And it's one of the most difficult peaks in the world to climb because it's got an ice cap on it. So you have to carry your ice climbing gear to get up to the top, and then you kind of have to actually go on your back to get around the edge of the ice cap. So it looks kind of dangerous to me, but people do it. And to the far south, Torres del Paine is a beautiful place to visit. On the left here is some of our team from a couple years ago. And TripAdvisor, they made it the 8th wonder of the world, if you can believe it. Another picture of the team, another Torres del Paine picture. If you go a little bit further south, you get the Beagle Channel, the nearest port to Antarctica, and kind of a big tourist place. In fact, nowadays, a lot of tourists, they go to Ushuaia and El Calafate as they travel. And a couple years ago, these folks from Ushuaia came up and helped us with our aerial photography. So we visited them and took a helicopter ride to the glacier, rode in the dog sled. Lots of unique animals in Patagonia. As a soaring pilot, my favorite is the Andean condors. And around the El Calafate area, you see a lot of them. So they're not endangered there. Also seen them farther up north when I've flown out of other places such as Bariloche. And typically what they do is they live in the Andes. In the morning when the soaring starts, they go soaring and they soar to the east out into the Pampa. In the Pampa, they gorge themselves on carrion. And then in the afternoon, they soar back to their roosts in the Andes. And there was one day I was flying out of Bariloche. It was about 7:30 in the morning, and there was a flock of condors already wave soaring. They were up about 6,000 feet AGL, having fun. Picture one of our Perlan teammates took of a condor soaring over the glacier. They have a lot of llama-like animals, guanacos they call them. They're kind of cute, I guess, if you're interested in good eyelashes. They have emu-like birds, coeques, and here's a bird, here's a rock. You can see that they're pretty well camouflaged. And they're pretty good runners. I clocked one at 35 kilometers an hour once. And lots of other birds. Flamingos. You know, as an American, I assumed that flamingos only lived in Florida. But we've seen them living in El Calafate in the wintertime. Okay, flying the Perlan 2. Here's a quick little video that Airbus put together. So taking the airplane out of the hangar, we fly in insulated clothing, basically ski clothing. Hatch comes in, turn it 90 degrees and seal the hatch. We've been towing behind the egret. This is a turboprop that I'll describe a little better later. We're using about a 240-foot rope these days. Interesting egret contrails as you get to high altitude. Some video from a tail camera. We do have our telemetry system working, and that was our ground control, Capcom we call them. And then coming back to land. We're trying to do as much research as possible while we fly these missions. We have been launching weather balloons in order to document the winds aloft and to help with our predictions. And kind of interesting, we have something we call a virtual cockpit. And basically the telemetry stream that we create goes to a website, and the website displays our location and some of our critical flight parameters. And when we went to do our first weather balloon, the Argentines are really reluctant to let us fly it because they do not have air traffic control radar in the southern part of Argentina. So they do all of their air traffic control via procedure, i.e. they separate people by significant altitudes and or significant amounts of time so that there's no mid-air collisions. And the intern who created the virtual cockpit for the Perlan also created a virtual cockpit for the balloon. And typically we launch the balloon only on days when there might be wave, which means there's a strong wind out of the west. And most of the time the balloons go up to around 100,000 feet. And by that time they've drifted all the way to the Atlantic Ocean. And when the balloon finally pops, they descend and land in the ocean. This is a typical sounding from a balloon. This one was taken on August 4th in 2017. This is the day when the polar night jet is really working. So there was a wind max of 125 knots at about 35,000 feet near the tropopause. And then there was a decrease. And this actually is not good for wave. This sudden decrease tends to reduce the propagation of the wave. What we prefer to see is a continuous increase in wind speed. But above 35,000 feet, there's a pretty nice, almost straight line increase in the wind speed. At 100,000 feet, the winds were 205 knots. And this is kind of what you would expect to see roughly on a good day. On September 3rd, 2017, when we got to set our first record, this is the forecast wind speeds at 100,000 feet. El Calafate again is where this cross is. Where the red numbers are, that's 200 knots, and actually where it turns purple, there's a little bit of a purple right here, 230 knots of wind went around to propagate the wave to high altitude. This chart shows the winds aloft from the equator to the South Pole. Of course, the scale is exaggerated vertically. But the subtropical jet, which is the jet that we see at temperate latitudes like here at Minden or at Edwards Air Force Base, where some of the other records have been set, tends to top out, as I've said earlier, at the tropopause. And above it, the winds die off, so you don't see the high altitude winds. But the polar jet, which occurs in the northern regions or in the southern regions, tends to be underneath this polar night jet in their wintertime. It appears that the polar night jet in the southern hemisphere is about 40% stronger on average than the one in the northern hemisphere. And I haven't seen a good reason why, except I speculate that the Antarctic is colder, of course, because it's a landmass versus the Arctic, which is the sea. But especially in the case of the Perlan glider, we had enough wind here to climb to here, and we're actually underneath the polar night jet on this particular day, this being almost 51,000 feet, 54,000 feet. This is a picture taken in the rear cockpit. We're using a commercial but modified navigation computer that is sold in the soaring world. It's connected to the variometer. This variometer is showing the climb rate, and this variometer is showing the netto, we call it, which is the climb rate in the atmosphere. That's the climb rate that the molecule of air would have if you were measuring how fast it was moving up. The moving map is extremely helpful when you're flying mountain wave because the wave lift zone tends to be linear, and we find the best spot and we zigzag back and forth always turning into the wind. We have an attitude reference given the shape of the windows and the fact that we often get frost on them. It's nice to have attitude reference to help you keep the airplane straight up. So in this case, we're flying just above stall speed. Here's our G. In this case, we've only pulled 1.5 Gs during the flight. And in this case, we're at 53,330 feet. For records in gliders, the FAI is now using GPS altitude for records above 15,000 meters, 49,000 feet. So we also need to concern ourselves with the difference. This being pressure altitude here. On some of our displays, we actually have the GPS altitude so that we can see what we're actually recording. The tail camera, we can see the tail camera image in the cockpit. And again, when the windows get frosted up, this is a good aid. And the 360 cameras, we can scroll around and see underneath and behind us and see what the clouds are doing. On the right is what we call our life support systems display. And it basically takes the data from our bus, and it has many pages where we can scroll through and look at various items. This page here is basically our safety of flight page, and it shows CO2 levels in the cabin. It shows oxygen supply, how much amperage we're pulling from the battery levels, and so on. This is a picture taken from the front cockpit on our first record, and you can see the frost. We've seen outside air temperatures as low as -70 degrees C. The temperature in the cabin varies from the sunny side to the dark side. So a huge gradient. Remember, the winds are out of the west, so we're flying pointed towards west most of the time. And we're in the southern hemisphere, so the sun is on the north side. It's pretty low because it's winter. As such, it's much easier to keep the windows frost-free on the sunny side. The one in the shade typically gets frosted over no matter what you do. And you get frost on the roof of the cabin. And in this case, we're approaching flight level 540. And our maximum altitude on this particular day. On the ground, the telemetry data are processed and displayed on computers, and we have a whole team. We also have some people that are familiar with the weather forecasts that are helping look at the updates to forecasts and providing information to the crew. This is an image of what the virtual cockpit does. And if you're interested in watching future flights, you can actually go to our perlanproject.org and sign up. You'll receive a Twitter warning when we're flying. And it shows altitude and vertical speeds, what the wind's doing. Some critical things like how much air we've got in the location over the ground. Picture from flight level 540. As you get up there, the sky is starting to turn dark, and a little bit of crank on the horizon, but absolutely beautiful. And this is landing after that flight. At this time, we're having trouble with flat tires. Basically, because of the cold, we're having trouble with, it's a tubeless tire leaking. But a couple of years ago, we got a new tire from Michelin, and we've got a better seal. The wheel is split, so it's got O-rings in it. And when those get cold, they tend to leak. So the lesson we learned in our second season was that climbing through triple pause was a challenge, but it did get us in the Guinness book. So it was quite a season. So in our third campaign, we added the egret. It allows very high tows. We've now towed over a dozen times to above flight level 400. Our highest tow to date is up to flight level 470. which would be records if they give a record for the highest tow. The highest other tow we can find is to like flight level 250, which was done with a C-141 pulling F-106 when the folks at then NASA Dryden did their test. But by taking these high tows, we're actually able to tow to the stratospheric wave. It turns out that at the tropopause, sometimes the tropospheric wave doesn't line up exactly with the stratospheric wave. The tropospheric wave does perturb the tropopause, so it creates the stratospheric waves, but because they don't line up, it's difficult to transition with the glider. So with the egret towing into the low 40s, we actually tow above the tropopause and get into the stratospheric wave. So, you know, before we took the egret to Argentina, we did a test in Texas to make sure that it would be a suitable tow plane. We installed a tow system that actually retracts the rope because we were concerned about the true airspeed at high altitude and the rope whipping after release. And those tests were good, but we only towed to about 8,000 feet when we did the tests in Texas. And my very first climb out, we're climbing past about flight level 250, the tow plane started making a contrail. And it really makes a contrail, but it's not a problem, except in this little zone right here where it crosses the rope, it tends to put ice on the rope. So when you release, the rope kind of whips and it sheds a little bit of ice. In fact, I'm going to show a short video here next. And you can see the glider releases start to turn. You can see the rope whip and you can see the ice come off. So the camera's looking through the contrail. And the rope just whipped there and the ice came off as the glider turns away. So on that particular day, for the highest flight, the flight level 760, the forecast said the weather would be good to the west-southwest. We towed there, didn't find anything. So we towed back more towards the west-northwest and found a line of lift. And we're just working back and forth in this line of lift. We occasionally went out of the line of lift because the lift was so strong, we were climbing faster than we needed to for our test points. So on this particular day, we're still doing flutter envelope expansion. So we released here, climbed 65,000, and we had a series of flutter test points we did there. We're doing both sweeps with the automatic system as well as stick wraps to excite all the axes. And at 70,000 feet, we had more flutter test points. Went to flight level 760. On the way down, we had some high-speed flutter test points that we got at 50,000 feet. And we had another one down at 20,000 feet, which are high-speed test points. For the entire flight, it was I think a little over 5 hours. It takes about an hour on tow. It took 2.5 hours or so to get to the high point, a little over an hour to come on down. We actually delayed our descent a little bit because of airline traffic. Again, they're doing all their airline traffic with procedures, and we're trying to be good stewards and good friends with the Argentines. The picture from inside the cockpit, flight level 760. Been a beautiful day. This is our LSSD showing the front O2 slightly low, but otherwise things are all nominal. We've got a piece of plexiglass that forms a plenum here, which helps keep the window a little bit clean. But when I'm flying, I'm using the window and the horizon as my two references. Some tilt camera video from flight level 760. The sky is a little darker than at 540. But again, you know, is a culmination of a life's dream getting so high. It's fantastic. This video was taken from the rear cockpit on one of our flights. You see the tail camera, our display here. I'm flying with a cover over the hatch just to reduce the solar radiation. This is the down sun window. And this is out the hatch, a little bit of frost on the hatch. And this image, remember I talked about Mount Fitzroy? This is Mount Fitzroy right here, just peeking out of the clouds from, in this case, 66,000 feet. So to date, the Perlan project has flown the world's 10 highest glider flights. You know, 5 times we've been above 60,000 feet and 9 times above 50. Our flight envelope, we've cleared the envelope out to this purple line. And we're now at the point where we decided we can go to 900 on our next envelope expansion. The red line here being our design limit, 121 indicated up to 30,000 feet. And then because of Mach effects, the maximum airspeed is decreased. The Mach limit is 0.62, which is 54 knots indicated at 900. We've flown as long as 6.6 hours, and we've now claimed 4 world records with Perlan. Our science data collection. The most important piece of data that we've collected is the fact that these waves actually do exist and that they have enough strength that you can soar in them. While we're soaring, we're gathering lots of temperature data, and we've actually seen some unexpected anomalies, which are worth some research. We're collecting radiation data, ozone data. In 2019, our data showed that the ozone hole has closed over at least that part of Argentina, collecting particles and dust and carrying CubeSats. And these are experiments which students have made, CubeSat being 10 centimeters or 4 inches on a side, little self-contained experiment. So this is flight 52. This is our high flight. And it just shows some of the deviations in the atmosphere. The blue line here is temperature data that were collected when we were climbing. And you can see it was extremely cold in the rising air. And then during the descent, you can see that it was warmer. And then the balloon data are the red data. The Perlan project has received a lot of publicity. Our friends in the Airbus media system are pretty good at writing stories and capturing film. They've documented over 5 billion impressions, they call it, where people around the world have seen images of Perlan. In fact, after our first record, I got an email from a German friend who is an Airbus 380 captain. He happened to be in Beijing at the time and said that it made the news in Beijing. So the Perlan has made the world's highest piloted subsonic sustained flight, or the highest by a civil aerodyne. Here's the view again from 76,000. Next step is flight level 900. So for your bucket list, I encourage you, if you're at all interested, to check out perlanproject.org. If you've never tried soaring, you should take a lesson. You know, in Southern California, you know, there's places like Crystal Soaring, Tehachapi Soaring, Warner Springs. They'd be more than happy to take you on an introduction. Or if you're in the Las Vegas area, if you go down to Gene, there's an operation down there that can introduce you to soaring. And Patagonia, highly recommend to visit. Put that on your bucket list. So the Perlan project, we've got lots of web presence, and I encourage you to check it out at perlanproject.org. My wife has done many, many blogs there, And if you go through the entire blog list, you basically can follow the construction of the airplane and all of the things that we've learned and all of the experiences we've had over the past many years as we've tested the airplane and claimed records. So with that, I'd be happy to move on to questions.
So Jim, do you want Jerry to say at the Q&A beginning?
Oh, yes, Jerry. Jerry had a few words about Einar, just to give Einar some additional credit for all that he's done. He's been a pretty amazing person.
Just a few minutes, a few seconds. He should be joining. And in the meanwhile, if anybody has you want to speak out, please raise your hand. You will be able to be unmuted. And Jim, at the same time, I think there's a couple questions in Q&A and some in chat. Okay, Jerry, go ahead.
Yeah, Jim, this is Jerry. I did finally get my microphone off, so I apologize. Just on Einar in the Volkson, I worked with him at the NASA Flight Research Center in the mid-70s. And after that, he retired. And Jim has told you about that. When I was working with him, he was flying these remotely piloted research vehicles. And I had the HIMAT program. He did 3 or 4 other remotely piloted vehicles. So flying him from the ground wasn't quite as exciting from a pilot standpoint, but he was an excellent test pilot. These pictures that Jim showed you of where he came back from this trip to Germany after he retired. And I think he was working with the DLR there in Germany. And as soon as he saw those photographs that indicated these high altitude waves, immediately he wanted to do this glider project. So from that point forward, his mind was set on making this happen. And you know, he led the early part of this program. He told me also that on his way back from Germany, soon after he had seen those pictures, he stopped at a restaurant in Iceland, and it was called the Perlan restaurant. So this whole project got its name from this Perlan restaurant in Iceland, which had a big glass dome in the top, and you could see some of these high altitude cloud patterns, I guess. So that's all I'll say about Einar. He was a great test pilot and is still alive and has bowed out of flying, but he did some of those early flights to record altitudes in the 50,000 foot range, as you saw in those early pictures from Jim. Just a couple questions that I'll leave with Jim. I wanted to know if you've actually completed the flight clearance, all the flutter test points and all that. Are you now happy with the certification of the vehicle, if you will, to be safe at the altitude you're going to? And then number 2, what are your thoughts about getting to this 90,000 foot challenge?
Okay, the challenge to get to 90,000 feet, I think, is extremely possible. On the day we went to flight level 760, we still had good lift. Because we're doing our buildup, we stopped so that we could analyze our data. To date, all of our flutter testing has shown that the airplane is behaving according to the model. So I'm confident that it'll go to 90,000 feet without any issues. Now, the Perlan actually is the Icelandic word for the clouds that are formed at high altitudes. So you're exactly correct. When Einar saw the restaurant, it kind of piqued his interest, and the name is stuck. Yes, and as you said in your presentation, all these test pilots are basically students of the atmosphere. And he told me about, while he was at NASA, hopping in F-104s and going up to investigate strange cloud patterns when they occurred there in the Edwards Air Force Base area. So he was very much a student of the atmosphere. He is, and I give Einar a lot of credit. you know, I'm kind of a pilot and scientist. He's more scientist. He's still an awesome pilot. Unfortunately, you know, he's getting up in the years, so he's not able to fly now, but he's been fantastic for the program. So looking at the chat here, John Chapman says, yeah, I misspoke. It's a DG 505, not a Grobe 505. Another comment, looks like a Burt Rutan design. And that's true. Their plane is built of pre-preg carbon. And if you're going to build a structure that is light as possible, you're going to end up with round windows. You know, kind of the same reason they don't have round portholes on ships. It's stress concentrations. So yes, it looks like a Burt Rutan design because that's the most efficient way of building carbon structures like this. Now, it looks like the windows were forged. I'm not sure what you mean by forged. The windows actually have dual panes in them. The outer window it's a polycarbonate, is actually bonded to the carbon fiber, which is a non-standard practice. We built several coupons and tested it. The interesting thing about the polycarbonate is the colder it gets, the stronger it gets. You know, if you put it in dry ice, it gets so tough you can't drive a nail through it.
Jim, that was fogged, not forged.
Oh, okay.
Bad typing skills on my part, Jim. And your
yeah,
picture
unfortunately, when it's so cold outside, it's almost impossible to keep the windows from fogging. You know, we've had desiccants in the cabin trying to reduce the moisture. You know, unfortunately, even though you're cold, your body's still off gas and moisture. The rebreather really helps. If we didn't have the rebreather, I think it'd be impossible to keep the windows where you could see out. But with the rebreather, the water concentration in the breathing loop gets to be 100%. And it actually is helpful to the crew because you don't dehydrate once the oxygen concentration gets to be 100%. So.
Jim, there are a couple of questions in the Q&A box. Would you be able to see it?
Okay, yes, pressurized cabin, absolutely. And that's been a fantastic success for us. We can go to 8.5 PSI differential. And let's see, would you possibly explain the true airspeed versus indicated airspeed V&E concepts a bit more? You know, basically, you know, the wing makes lift as a function of the mass of air that's going over the wing. So as the air gets thinner, I have to fly actually faster through the air to have the same mass of air going over the wing. Another way of thinking about it, if the air is thinner, to get the molecules in the pitot tube to make indicated airspeed, I have to go faster. And you know, at 90,000 feet, the air density is roughly on the order of 3% of sea level. So you got to go pretty fast in order to get maintain level of flight. Another question, is there a difference between soaring and gliding? Yes, but basically a sailplane is a glider which is efficient enough that it's able to soar in rising air. Now, I've seen mountain wave that was strong enough that you could soar a beaver, you know, a U6 or something like that. So, but typically, you know, the cargo gliders that they used in World War II, those are gliders, but any modern sailplane is capable of soaring. Okay. Do we have to modify our electronics to protect against moisture and humidity? We did not, and it has not been a problem. I know in other situations, people have had moisture problems, but so far, we haven't had to do that. Dreams for the next 5 years of the Perlan project. Well, unfortunately, traveling to Argentina is rather expensive. And we have saved back enough money from the donations that we've gotten, Airbus being our primary donor, that we're able to go to Argentina one more time. After the next trip to Argentina, we'll need to raise some more money to go back a second time. However, one of our focuses has been science. And now that we've been to high altitude, we're actually talking to several organizations for potentially carrying some other science payloads. Are we working with any meteorology researchers? Absolutely. Last year we had a PhD student intern, or actually 2 years ago now, in Argentina with us. She is actually in the local area. She lives in Carson City, and she's going to the University of Nevada at Reno. And she is doing meteorological research. Weather Extreme is a company that also is based in Reno that has been actively involved with the Perlan project since the inception. Elizabeth Austin is the CEO of that group. And she got connected up with Steve and Einer back in the 90s. And her organization has done a lot of research. Okay, describe the life support system and any bailout capability. The life support system, of course, the pressurization system is key. Secondarily, the rebreather system is a key. Without the rebreather system, we would end up with too much oxygen in the cabin, and we'd have to worry about a fire such as Apollo 1 unfortunately had. Pressure suit, the airplane was designed to be used without pressure suits. Getting in and out of the cabin with a pressure suit, we'd have to redesign the hatch and make that much larger, so it'd be much more difficult to build the structure. As well as a pressure suit, it's going to add quite a bit more mass, pressure suit and all the systems that go with it. And the bailout capability, we have no personal bailout capability. We're relying on the BRS to let us down if we have some sort of failure that would deem bailout is appropriate. And why a two-person crew? Number one, that's the way when the program was started, Steve Fawcett wanted it. It turns out when you're doing research type stuff, it's really great having a two-person crew. My first fighter was F4, so I learned to fly with Wizzo. And actually a crew of two working together is a really fantastic team. So it's just been good for us having a crew of two. Did I miss any questions?
John, do you want to speak out, Mr. Chapman?
Jim is an outstanding pilot who's obviously done many things. What makes the show go round are dreams. His dream brought it this far. We'll see how long it continues.
Thanks, John.
Certainly.
Yeah, Mark, Colonel Pestana, do you want to say something? Or Santosh? All right. I do have a question. You mentioned you have the CubeSat from the students. So is it something that Perlan is going to have more mission, so students can carry more CubeSat?
Yes, most of the CubeSats that we have flown to date were the result of a group called Teachers in Space. And the Teachers in Space have had little competitions among schools to build CubeSats. They also fly CubeSats on balloons, and in the past, they flew some CubeSats on the space shuttle. So if you're interested, or a school is interested in potentially building one of these CubeSats, probably the best thing to do would be to go to perlanproject.org and talk to our science committee.
Okay, I think there's, I think Jed and Jerry in the chat, there's some question.
Okay, I see. Why does the VNE decrease at higher altitudes? Well, there are several things that determine what the VNE is on an airplane. In particular, our VNE is 54 knots at flight level 900 because of Mach effects. At that speed or that altitude, the true airspeed is so high that if you go past 54 knots indicated, you're going to start getting local shock waves on the top of the wing. And those local shock waves, first thing they do is they increase the drag, which means you probably won't be able to climb. And as they get larger, they potentially could cause stability issues. Typically, you could expect the airplane to kind of pitch down. You've probably heard stories of the P-38 not being able to recover from dives until they put the air brakes on it. And basically what they were doing in the P-38 is they were getting to the point where they're getting shock waves, particularly on the tail. And when there's shock wave in front of the elevator doesn't work very well. So in their case, they had to slow down. So in our case, we'd probably pitch down, and we are flying at a relatively aft CG, so the elevator is not very highly deflected, which will reduce the chance of a shock wave getting on the tail. In our case, we've got air brakes on the top of the wing. We can use to slow down. And if we had a really bad upset, we could use the drogue chute to slow ourselves down. But basically, in our case, it decreases because we'd start getting shock waves if we flew faster. Okay, and how does our flight experience translate to NASA flying on other planets, Mars, and so on? Well, the Reynolds number at 90,000 feet is pretty close to the Reynolds number you would see on Mars. So there can be some, learning from the airfoil that we have. When I was teaching at the Air Force Academy back in the 80s, AIAA, I think it was, had a design contest for students. They were asked to design an airplane that would carry 2 people wearing spacesuits from one operating location, 50 miles to another location, land, and then take off and fly 50 miles back. And I don't recall what won, but the design that the cadets made basically looked like a giant Gossamer albatross. If you remember the man-powered airplanes that Paul McCready made, because the air is so thin that you really need a low wing loading. Now, fortunately, gravity is only like 0.38 of Earth, so that helps you a little bit. But you have to carry your oxidizer because there's no oxygen. So any engine you use has to have an oxidizer supply. So anyway, they made this giant airplane that's designed for very low Reynolds numbers.
Yeah, talking about this Mars plane, actually, Dr. Dan Raymer, he presented his design of Mars plane in our New Space mini conference early this year on April 18th. So it looks like people are truly interested in the plane in other planets. Hello, nice to see you. That's your Mrs. Payne. That's Jackie.
No.
Yes.
Yeah, nice Glacier picture movie. That's great shot. So cool. Yeah. So
Question here about the presentation being available at perlanproject.org. We have not posted any copies of a presentation like this at perlan.org. This is being recorded so AIAA can, post it on their website or whatever.
Jim, just a quick question. I mean, this is really exciting, but do you or Perlan consider this going to be a possible platform for future space tourism?
Well, the problem is to get to these high altitudes, you have to go someplace where the polar vortex is working. And unfortunately, I can't tell you which days that's going to happen. Like I can give you a season. So I can tell you that if you go to Argentina between the middle of July and the middle of September, there will be some days when you can soar to high altitude. But, you know, unlike a rocket plane where I can say on December 15th, we're going to fly it to 50,000 or 500,000 feet. We're at the mercy of the weather when we're soaring pilots. So you have to be patient.
Yeah, understood.
Yeah, Jim, just comment on your high altitude engines. NASA back once upon a time did what I call a reciprocating rocket. So it was a reciprocating engine that was fueled by, I think it was hydrazine, and used no oxygen, but it was nonetheless a reciprocating propeller-driven flying machine at very high altitudes.
Oh, wow. Yeah, the trouble with reciprocating engines at high altitude is cooling.
Yeah.
You know, it's much better to have a turbojet at the high altitude because the airflow keeps it cool.
Oh, by the way, Jim, you mentioned about this in your cockpit, you have the detection of radiation. So what is the radiation level there? Do you have to wear some kind of radiation badge to monitor the health, you know, for you or something?
We're wearing a badge. It's probably not much more than a captain gets if he flies a 12-hour flight from, you know, Canberra to London or something. So yeah, we're getting a little bit extra. You know, I do have a carbon fiber on top, and I often fly with my cover over the hatch, so that reduces it a little bit. But you know, we're accepting that little bit of radiation exposure.
Yes. Okay. So, any further question, Mark? Do you want to say something? Colonel Pestana?
No, I just really enjoyed the presentation, and my questions have been answered. So, and I've seen Jim give other presentations, so this is wonderful. Looking forward to 90,000 feet. Wow.
So are we.
Thank you.
So, any further questions? All right. So, if not, let's thank Jim. You know, so wonderful presentation, and look forward to further. Oh, there's one question, Papa. Oh, thank you. Okay. Mr. Wishiyama says thank you. All right. So thanks everyone. Thank Jim for this fantastic presentation, and look for further opportunities with Jim, and see further exciting development for his flight and the Perlan project.
Well, thanks, Ken. It's been my pleasure.
Great pleasure, honor. Thank you. Okay. So our next speaker is Lieutenant Colonel Mark Hasara. He's going to present a very exciting, this exciting story about the time-sensitive, time-critical air refueling missions. So we post, you know, two articles in our newsletters about his September 11 experience. Basically, he was protecting our sky during the September 11 and other important occasions, missions. So Mark is the author of Tank Pilot, Lesson from Cockpit. He's a professional speaker, you know, AVA, navigate, and communicate. He's also founder of Wall Pilot, aviation graphics for the walls of your home or office. Yes, we actually have been trying to see if he can tell us a little bit more about that. Lieutenant Colonel Hasara is a former Air Force KC-135 pilot, international businessman, and a consultant in the defense industry, directing the creation of the world's only graduate-level air refueling planning and operations course. He developed 5 times after September 11, leading a team of 30 international airmen responsible for all air refueling operations across 3 continents. Mark authored the book Tanker Pilot, Lessons from the Cockpit in November 2017, published by Simon and Schuster describing his experience and relating them to core elements of success on the battlefield, in the boardroom, or everyday life. Delivering over 5,000 presentations to military and international business leaders, he continues to write and speak about experience and lessons learned from 4 wars and the business world. Mark and his wife, Valerie, are the parents of 5 wonderful kids and currently live in Utah. Let's welcome Lieutenant Colonel Mark Hasara.
Thank you, gentlemen. It's great to be here with all of you. I'm trying to bring up the share my screen here. Today, what I want to do is speak to you about time-critical operations in what we call in the military a joint environment. And when I say joint, I mean not just the military services, but also government agencies and working with governments of other countries. We will never fight another war with just the Air Force involved or the Navy involved. All military operations are now going to be joint because each one of the services and government agencies bring assets to the fight. In joint operations, particularly now, joint operations combine 3 very distinct principles. The first is joint integrated fires. What I mean by integrated is like the opening night of Shakana, where you have Navy fighters flying missions near Baghdad, cruise missiles coming in from submarines and ships, special forces on the ground interacting with guys in the air. By fires, I mean kinetic and non-kinetic. Kinetic meaning warheads, non-kinetic meaning like electronic attack. All of those things are considered fires. Persistent intelligence, surveillance, and reconnaissance is our ability to see an enemy, establish patterns of life, and from those be able to strike anywhere on the face of the planet. And we can literally strike anywhere now. And that's one of the stories I'm going to tell you in this lecture today. Second, our third is continuous humanitarian operations. Many people don't know that during the war in Afghanistan, C-17s were dropping as many as 32,000 food packets out of the back of the airplane. The Air Mobility Battle Lab in Fort Dix, New Jersey had created a cardboard box that we literally dumped thousands of these humanitarian daily rations, HDRs, and a C-17 would fly over some of the drop zones and drop 28 to 32,000 of these things in the middle of the night. Other types of humanitarian operations are the tsunami relief after the big earthquakes in the Pacific back in the 2008 timeframe. C-17s and C-5s loaded with lumber and visqueen, sheet plastic, were flying over to the Far East, and the lumber and sheet plastic was used to make housing, temporary housing. But I think all of us understand that air power, naval air power, Marine air power, Army air power, and particularly Air Force air power, gives the US some very distinct advantages around the world when it comes to these 3 principles of joint operations. everything that we do falls into one or sometimes all three of these categories. And I'm going to talk about that as we go along here. So whenever we're doing something on a joint level, we're always thinking joint integrated fires, persistent intelligence, surveillance and reconnaissance, and continuous humanitarian operations. But what enables all of this? Air Mobility Command, that owns the tankers and the airlifters, is always tasked in these three principles. Air Force tankers participate in just about every joint operation, and there's three reasons why. Tankers increase the range, the payload, and the endurance of the airplanes that they reach out and touch. For range, those C-5s and C-17s were taking on as much as 280,000 pounds of fuel near Alaska and Misawa, Japan, in order to make it down to Utapao, Thailand, with a humanitarian effort. Increasing payload, they can take off with less fuel because they can touch a tanker shortly after takeoff to fill up their tanks. So that way they can carry more cargo in the big airlifters. Endurance is being able to keep an airplane airborne for long periods of time. Some of our intelligence assets will fly for 12 hours, 8 to 12 hours, getting anywhere between 1 to 2 refuelings during their flight. Typically, an RC-135 on a strategic reconnaissance mission will receive 80,000 pounds from a KC-135 or a KC-10, and they'll need that every 5 hours. One of the things that I've learned, and I actually taught when I was at the Joint Forces Staff College, was the CNN effect. And what the CNN effect is, gentlemen, is we know that correspondents are all over the planet. And within 5 minutes of something happening, it's pretty much broadcast to the world. And we even plan on that. As an example, when the 173rd Airborne Brigade made its parachute jump into the town of Bashur during the 2003 invasion of Iraq, there was a reporter embedded with him, and they taught him everything a paratrooper needs to do to jump out of an airplane. But he was told that he could not start broadcasting or filming for 10 minutes after he landed so that they could get everybody on the ground. 938 paratroopers and equipment came out of 15 C-17s in the space of about 4 minutes over this airstrip in northern Iraq called Bashur. We called it the jump into Bashur, and it was amazing to watch from the command center where I was at. Second thing, often we will have intelligence on some type of operation or event that is happening around the world. Our intelligence apparatus is pretty lengthy, pretty experienced, sometimes very intense. And often US forces will be energized based on intelligence reports, threat warnings will go up and so forth. Those of you who have been in the military understand warning orders and those kinds of things telling you, hey, get ready, here we go. But often the CNN effect and these intelligence sources give us information that is very time critical, and we have to react sometimes in less than 24 hours, sometimes 96 hours, which takes a lot of coordination, with a lot of agencies throughout the government, coordinating with other governments around the world to accomplish things. And there's two stories that I want to share with you today that talk about joint integrated fires, persistent ISR, continuous humanitarian operations, and tankers increasing the range, payload, and endurance of airplanes so that we can accomplish the mission. Korean Air Flight 801 on the 6th of August in 1997 was approaching Agana International Airport. The island of Guam was still feeling some of the effects of a typhoon that had gone by. So there was low ceilings, some rain, and other things that were affecting the island. The captain of the aircraft had been up for a while. They had changed his assignment, so he was tired. The first officer and the engineer were fairly fresh. And on the first leg of their flight from Seoul, Korea, they were going to land in Agana, Guam. As they came into Agana, Guam, part of those weather phenomenon were affecting the approach into the airfield. Visibility had gone down due to rain. The winds were fairly light down the runway, but visibility had dropped while they were on the approach. Unbeknownst to them, they were flying an instrument landing system ILS approach, and the glide slope had been NOTAMed off. There was a lot of discussion inside the cockpit about what was going on, but because of the Korean culture, the first officer and the flight engineer didn't speak up initially. And when the first officer finally did speak up, it was too late. 6 seconds later, they crashed. On Nimitz Hill, about 4 or 5 miles short of the runway. In the middle of the night, about 1:42 a.m. Guam time. "229 passengers perished out of the 254 that were on board. Flight attendant and passengers were walking around the burning aircraft, and news crews were alerted that something was happening on top of Nimitz Hill. The tower finally saw the wreckage and the post-fight fire from Agana's tower and immediately called for crash and rescue. But a reporter made it up on top of the hill first. Air Mobility Command has a nervous center at Scott Air Force Base that we call the Tanker Airlift Control Center, which now called the 618th Air Operations Center. On that August 1997, that's where I was assigned. It was about 10 o'clock in the morning, our time. And I will admit to you, gentlemen, I was running missions and airlift missions and so forth, but it was a very boring day. And I'd come in at 6 o'clock. It's now 9:42, and I'm bored out of my mind. And I'm trying to find things to do when I look up at the TV that's in front of me, and I see that banner that you see on TACC, breaking news. And it just kind of caught my eye for a moment. I thought, okay, well, you know what's going on. And it shows this reporter, and he's reporting from on top of Nimitz Hill. And he's saying, a Korean Airlines 747 has just crashed here on top of Nimitz Hill. And as they were panning around, looking at the aircraft and looking at the hill, I noticed the navigational aid for Guam sits on that same hill. And as he panned around, there it was. And I saw immediately, this is Nimitz Hill. There's the Nimitz TACAN. And I reached over and I grabbed the lieutenant colonel by the shoulder and said, boss, we're about to get busy. And he goes, what? What's happening? And I said, look what's on the CNN banner right now. And he watched for a few seconds as the thing was going by, and they were talking about the rain and the wind. And he looked down in this gully, and people are walking around with the airplane burning. He immediately calls over to the senior controller, who's a colonel, Colonel Bailey, and says, Colonel Bailey, you need to turn up CNN. And one of the great things about being a colonel is you get your own TV. He turned around with his remote, turned it up, and he was listening to the same news report. And this reporter kept reporting that there are people walking around, the airplane is still burning, there's been this crash on top of Nimitz Hill. And Colonel Bailey looked at Colonel K and I and says, well, guys, come up with a plan, because you know very soon we're going to get a phone call. And he looked at me specifically, he says, Mark, you just moved from over there. You know the lay of the land. Come up with something, because you know in 30 minutes we're going to get a phone call. Colonel K and I looked at each other and said, okay, we're starting with a white sheet of paper. We have nothing right now, but we've got to come up with a plan. So he told me, okay, look for a C-141 that we can send over there, that we can configure as an air ambulance. State Department's probably going to call pretty soon, and we may get a phone call for somewhere else engaging us in this. I looked through all of our computer screens looking for a C-141 with a crew that could fly for 24 hours, and I couldn't find one. As I'm going through everything, finally, I find a crew and a 141 at Andrews Air Force Base that is just coming off what's called a Phoenix Banner mission, which is presidential support. It's what we call an augmented crew. So there's extra pilots, extra load masters that can fly for 24 hours. And I think this is great. We can use this. Problem was, they were still asleep. They weren't going to come in for 2 more hours. We ripped off that airplane, put it in the system, and began working our magic. About 28 minutes later, we got a phone call at Scott Air Force Base from Vice President Al Gore's office saying, an airplane has crashed in Guam. What can you guys do? Colonel Bailey took that call and said, sir, we're already working a plan. And he looked over at me and he snapped his fingers like this to get my attention. And he pointed at his phone, and I heard him going, yes, sir. Yes, sir. Yes, Mr. Vice President. And I went, okay, this is going to be a very high visibility mission. No mistakes. But now we had our airplane, an airplane that we could configure for just about anything we needed. Shortly after that phone call, we found out who was going to be on the airplane. The National Transportation Safety Board has what they call a GO team of about 18 members. There's an engine mechanic, an airframe mechanic, I shouldn't say mechanic, experts, air traffic control, medical, and this 18-person team is ready to go at a moment's notice. That was going to be our cargo. But in order to make it from Andrews Air Force Base halfway across the world to Guam, we needed to find tanker support somewhere around the West Coast so that they could fly nonstop from Andrews Air Force Base to Hawaii. So I began scouring things again. And in the back of my mind, I remembered something one of my college buddies told me. The KC-10s that are stationed at Travis Air Force Base near San Francisco will fly their training mission in pairs. They will take off, go to an air refueling track called 7 Alpha Bravo. AR 7 Alpha Bravo, gentlemen, runs from Mendocino north along the Sierra Nevada mountains from 21 to 28,000 feet. Near Portland, it turns west out over the ocean for about 30 miles and then comes south back to Mendocino along the Oregon and California coasts. The KC-10s will go up and practice air refueling with one KC-10 acting as the tanker, the other one is the receiver. And when they make the turn west at Portland, they swap places. So now one becomes the tanker, two becomes the receiver, and they will fly back down to Mendocino and get air refueling training. And I thought maybe there's a training flight of KC-10s leaving Travis Air Force Base. And as luck would have it, within 30 minutes of the window I needed air refueling, there were two KC-10s taking off on a training mission going to AR 7 Alpha Bravo. And gentlemen, all of us understand, I would rather be lucky than good. And today, we were lucky, very lucky, that all of these things fell in place like they did for us to be able to move this National Transportation Safety Board team. We scheduled 80,000 more pounds of gas on one of the KC-10s, and the C-141 crew finally called in, and we told them, you're not going home to Charleston, gentlemen. How would you like a tour of Hawaii and Guam? And the pilot of the airplane said, I don't know, sir. This is really gonna suck. Hawaii and Guam, yuck. And of course, he was being facetious. But I told him why he was going. Still makes me emotional. I said to him, Captain, you and your crew have the opportunity to be involved in something really great. You're going to help some people that are badly injured or badly burned. I don't know how, but I just know we need to get you there. Will you take the mission? Because you see, that crew had the ability to tell me yes or no. They were supposed to go home. And of course, this young captain said, you know, Major Hasara, we want to be a part of this rescue. Anything we can do to help the victims of Flight 801, we want to be involved with. And I said, great. You're not going empty-handed. The National Transportation Safety Board GO team is going to meet you. They got out to the airplane about 20 minutes before they shut the doors, and the C-141 took off. Going across the country, we were able to relay more information to them, gave them their air refueling information, and sure enough, right on time, they turned at Mendocino heading north and got 60,000 pounds from one of the KC-10s, which allowed them to continue going onto Hawaii. Now, all of this planning and execution happened in the space of about 2 hours. The National Transportation Safety Board GO team told us they have to be on the island of Guam within 24 hours. They could not accept past that 24-hour time frame, because this was the initial team that gets over there and starts sifting through all the evidence and all the things that are going on. The C-141 landed in Hawaii as a refueling stop. They switched crews in the airplane. One crew actually stayed in Hawaii. One crew got in the seats. And that 141 landed at Anderson Air Force Base 17 hours after notification that we needed to have them there. Now, when they got on the ground, the National Transportation Safety Board GO team immediately went up to the mountain and began sifting through the wreckage. And I went home to sleep. My crew, the crew that I was on with, Colonel K and about 7 of us, finished our shift, and we went home to come back the next morning. When I came back the next morning, of course, I immediately brought this situation up in the computer to see what was going on. And I had found out that we were sending another 141 to Bozeman, Montana, and then on to Guam. And I thought to myself, what in the world is in Bozeman, Montana, that we have to go there to save people in Agana, Guam? And I learned something very important. And again, this is where joint operations comes into play, gentlemen. This is where government agencies begin talking to each other, and all of these separate pieces come together to help in this humanitarian operation. What I didn't know and what I didn't realize was Bozeman, Montana is the main warehouse for the smoke jumpers equipment. All of the guys that fight fires by parachuting into the areas where these raging fires are going on, forest fires are going on. One of their major warehouses is in Bozeman, Montana. But I still didn't understand smoke jumpers in Bozeman, Montana. I couldn't put that together. Inside that warehouse, they have, for lack of a better term, a container that they put the burned smoke jumpers, the injured smoke jumpers in that are badly burned. And inside those containers, they can move them to other places to get medical care. What they were going to do, the C-141 was taking off from not Charleston, it's in McCord Air Force Base, flying to Bozeman and then flying to Guam. Was they were going to Bozeman, the 141, to pick up those containers, but they also had very specialized burn doctors in Bozeman, Montana, to help treat the smoke jumpers. The 141 was going there to pick up, I think it was 8 of these containers. And I don't want to call them coffins, but that's kind of what they look like. They have a cover on them and all kinds of things that you can stick your hands in to work people on and so forth. And these doctors that specialized in burn victims were going to hop on the airplane in Bozeman and then fly across the ocean, stop in Hawaii, get gas, and then go on to Guam. Because there was 4 patients that were critically burned. One American, a 9-year-old girl named Gracie Chung, who had survived the crash, but was badly burned because she was trying to get her mother out of the burning airplane. And 3, I think it was 3 Korean nationals that were also very badly burned. Now, the State Department and government agencies are obviously talking to the Koreans, and this has become a big joint operation with a lot of moving parts. And I'm just concerned about getting this 141 over there now. It goes to Bozeman, picks up the doctors, picks up the burn victim containers and flies them over. They get to Guam, and those 4 people are put inside the containers. The doctors, smoke jump doctors, begin working on them. They put them again back inside the C-141, and we schedule a refueling for it. So it's going to fly nonstop from Agana, Guam to San Antonio, Texas, with these burn victims on it. Why San Antonio? The Army's burn hospital for its burn patients is in San Antonio. And they're going to fly those people directly from Guam to San Antonio and have them worked on in San Antonio at this Army hospital. Do you see how all of this is joint? By joint, I meaning multinational, multi-government agency. And this goes on all the time, gentlemen, behind the scenes. They fly the victims to Guam, from Guam to San Antonio, and they begin working on them. Unfortunately, gentlemen, little Gracie Chung, in the middle of her 3rd surgery, dies. And as you can see, we were all heartbroken. But 3 Korean nationals had an incredible story to tell. These Korean nationals, I think it was 3 Korean nationals, had this incredible story to tell of how the Americans went to all this effort to save them. The other really heartbreaking thing was to see Gracie's father come to the hospital. And like I said, on her 3rd surgery, she passed away on the operating table. But you know what? All of us have compassion. In a situation like this, if we have the ability to be able to get involved and help save other people that may be a world away, we're going to do it. And I know all of you feel that way. And one of the things our air power gives us is the ability to show compassion. There are flights like this that happen all the time, particularly bringing wounded soldiers home from Afghanistan and Iraq. There's air ambulances on KC-10s, KC-135s, C-17s that are moving patients all the time. But you can imagine the satisfaction we had when we found out those Koreans were alive. They were going to go home with an amazing story. And every year on August 6th, they have families of the victims and some of the survivors come to a black obelisk that's now on top of Nimitz Hill, commemorating this particular event. And many of them talk about how the American government expended a lot of energy and a lot of fuel in order to go and help save those people. Now, the next one I want to talk about real quick is intelligence. We have incredible intelligence capability. And I know some of you are thinking, well, we've gotten it wrong. Yes, we have many times, and I'll admit to that. I was part of the Iraqi invasion looking for the WMD, and we all know what happened there. But every once in a while, about 6 times out of 10, that intelligence is not only correct, but is something that we will actually act upon. Just a couple days before President Barack Obama left office, he gave the go-ahead for a mission that was called Odyssey Lightning. Part of the Odyssey Lightning operation going on in Libya was attacking the ISIS cells that were coming there to make Libya part of the caliphate. And they've got really good intelligence that there were 2 ISIS camps near Sirte, Libya, that may have up to 100 ISIS fighters in it. Africa Command immediately got energized on this. And in operations like this, gentlemen, special forces are always the first ones to show up. When I was teaching in Virginia Beach at the Joint Forces Staff College, I had a gentleman in my class who was part of the very first Special Forces team into Afghanistan 2 weeks prior to the actual bombing campaign starting. And he had married up with Hamid Karzai and was part of the team that was running around with Hamid Karzai. And he was a special tactics guy from Hurlburt Field. AFRICOM said, we got to do something about this. The first thing they did was put this special forces team near these 2 camps to kind of watch what was going on. As these 2 camps began to expand with tents and the number of people, we began flying drones, Reaper and Global Hawk, at high altitudes over the top of the camps to do what we call establishing patterns of life. And establishing those patterns of life is really important when you're about to do operations and joint integrated fires against a group like this. But that persistent ISR that I keep talking about allowed us to keep these assets overhead, keep the special forces guys on the ground, and we were able to really create a pretty clear picture of what was going on in these camps. There was more arms and ammunition coming in. They were starting to collect there. And like I said, at the before we did this operation, there was up to about 100 ISIS soldiers, fighters inside this camp. But how were they going to attack such a large number? They came to the Air Force and they said, this looks like a good opportunity for a B-2 mission. 96 hours before they were to put bombs on target, 8th Air Force was contacted by Global Strike Command and told to prepare for a potential 33-hour-long flight mission to Libya and back to strike these 2 camps. 96 hours is what they were given. I happen to know the KC-135 tanker planner at 8th Air Force. He, of course, needed to contact the Tanker Airlift Control Center to coordinate all the gas and so forth, because now what's happening is the B-2s are going to fly from beautiful Knob Noster, Missouri, outside Kansas City, to Nova Scotia, across Greenland and Iceland, down by England, through the Straits of Gibraltar, to their target, and then reverse route. 33 hours in the air is the initial plan, is how long it was going to take. So they get everything together. They start loading up airplanes. They're given their call signs. Clip 11, Clip 12 are the name of the 2 B-2s. Actually, there's a third one that takes off with them because of redundancy. You want to make sure that you have 2 airplanes. You always launch 3 to get 2. And its call sign was Clip 13. In 2003, they had done testing on loading B-2s with up to 80 500-pound satellite-guided JDAMs, 80 bombs in its weapons bay. There's a great YouTube video that shows them testing the B-2's capability to strike numerous targets along a mile-long runway with simulated buildings and everything around it, simulated airplanes, hangars, a surface-to-air missile site, all within a mile. And a B-2 came over the top of this target area in the Utah Test and Training Range and dropped its bomb load, and they smacked every one of those targets. And in some cases, gentlemen, the 500-pound bombs actually went through. They use shipping containers, cargo containers, and they'll put them on end and stack them up and so forth to make buildings and put a U shape to make a revetment and so forth. Every one of those places that they wanted a bomb to hit either had a bomb go through the shipping container or hit within a few feet of the truck, the airplane, straight down the runway and so forth. One pass, one B-2, 8-0 bombs. And this is what it looks like inside. This is the actual picture of one of the B-2s in its bomb bay that left Whiteman Air Force Base on this mission to Libya. You can see all of the joint direct attack munition, 500-pound bombs, all loaded inside the B-2's bomb bay here. And you have to remember, each one of these can be individually programmed to hit a specific target. They take off on the night of the 17th. They've got an 18 January time of over target. They're flying across the United States, and something very interesting happens. Those of you who have been to Europe know that the aviation enthusiasts over there have some mad skills. And many of them watch on Flight Radar 24 some of our Air Force bases to see what happens to be flying. And through the ADS-B transponder codes, they are able to follow these missions going on. And one particular gentleman in the United Kingdom happened to be watching Whiteman Air Force Base and sees 3 B-2s take off like this and head toward Nova Scotia. And he thinks to himself, there's something going on here. He goes to Boston Center's air traffic control radio online and is listening to a tanker doing S-turns, and he sees it doing S-turns on his computer because of the transponder, and hears the call sign of its receiver, clip 11. He's able to go into some FAA location, and he actually pulls down the flight plan of clip 11 flight and sees it on a screen in front of it. And he starts plotting it. And he sees it goes to Gibraltar. But thank heavens this British gentleman realizes something's going to happen and it's going to be epic. And he doesn't tell anybody about it. He just starts taking screenshots on his computer as the B-2s are flying across. The B-2s stealth up in Gibraltar and head into the Mediterranean. They have a hold point north of Sirte, Libya, so that they can work out the timing. As they're coming through the Mediterranean, they're getting more and more target information. Here are things we need you to hit from the Special Forces guys and from the Reaper UAV drone guys that are looking at the camps and watching the camps and go, hey, you need to drop a bomb here, you need to drop a bomb here, you need to drop a bomb here. So they start reprogramming the bombs. And this is not a very simple task, okay? Steve Jobs did not design this inputting of all the data. They're having to punch numbers, lat longs, and so forth into their computer and put it in each one of these different bombs, but they're able to load all this stuff up. So finally, they come out of this holding point. They begin heading south, and on station over the top of these two camps are two other special forces, Air Force Special Operations airplanes. They're a twin engine. I can't remember the name of the airplane, but it's got all kinds of a sensor ball and all kinds of listening things in it. And it's over the top, one over one camp, one over the other. So you've got drones, you've got special forces on the ground watching. You have these Air Force Special Forces airplanes that are also gathering intelligence, all of them watching these sites as the B-2s turn south and start heading line abreast for these two targets. They drop their bombs within 10 seconds of their appointed time, and all the bombs start coming out. One B-2 drops about 60, the other one drops about, I think it was 28, and things start blowing up in this camp in the middle of the night. It's hitting the tents, it's hitting ammo storage areas, it's hitting trucks. They're doing all kinds of damage to this thing. As they head south, go over the top, they turn around and come back for any reattacks and hold off of the coast of Libya. And the two Reaper drones begin cleaning up some of the things that weren't destroyed with Hellfire missiles. About an hour later, the B-2s are cleared off to go home, and they begin going back. This is where our British gentleman comes back online, and he actually records the screenshot on his computer of where the B-2s are in their racetrack pattern, getting gas on their way home just west of Gibraltar. But he still doesn't tell anybody until he finds out that they're now up near Iceland, and then he goes on Twitter. And sure enough, he takes all those screenshots and shows that some of the tankers came from England, some of them came from Zaragoza, and on one of those Mildenhall tankers out of the UK, there happens to be a gentleman with a camera. This is an actual picture taken of one of those clip B-2s on its way, I'm told on its way back to Whiteman Air Force Base, getting refueled so it can make a return trip home. Now, there was 13 tankers involved and 13 air refuelings. The B-2 takes about 80,000 pounds during these missions. And I remember writing on Facebook, hey, B-2s just flew a mission to Libya, probably needed about 1 million pounds to get there. And that post kind of sat there for a while, and people were talking about it, and people were posting stuff on Facebook, to me. And all of a sudden, something showed up, and it said, "Sir, not 1 million pounds, 955K exactly." And of course, I went, where did this come from? Okay. I'm not going to say the gentleman's name, but I came to find out that he was the 8th Air Force tanker planner who was designing the air refueling program system for this particular Odyssey Lightning mission. So 2 B-2s, actually 3 B-2s, the third one turned around at Nova Scotia and came home, took on 955,000 pounds, dropped 63 bombs out of one, I think 24 out of the other, and turned around and came home. But again, do you see how all of this fits together? You have special forces, You have the Navy was also involved in this particular mission. There was 2 U.S. Navy destroyers that were parked off the coast of Libya during this mission to monitor the B-2s, and if something happened to find the B-2s and were going to follow them out, they would take care of them. They would shoot down any airplane trying to follow the B-2s out. So you have special forces, you have the Navy, you have the Air Force, possibly the Army, you have drones, ships, airplanes, tankers, all involved in this one 33-hour mission. Now, 2 funny stories from this. During the war in Kosovo in 1999 is when the B-2s flew their first combat mission. They were flying about 28-hour missions. There's a Walmart in Knob Noster, Missouri, and the manager of the Walmart could not understand why in the middle of the winter, folding lounge chairs, like beach chairs, were going out of his inventory out the door. And he couldn't figure this out. And he's like, why in the middle of the winter here in Missouri, and only you've been to Missouri in the wintertime in January, it's cold. Why are these beach chairs going out the door? He saw a guy one day, a gentleman, walking out with 2 of them. And he stopped him. He goes, sir, I have to ask you, where in the world is this beach you're taking these chairs to? And the guy smiled and said, sir, I'm not using this for the beach. These particular lounge chairs fit perfectly over the top of the entry hatch of the B-2. We can lay these out, put a sleeping bag on it. And what we do on these long missions we fly in the B-2 is we'll trade off sleeping. So one pilot will fly, we're both in the seat for air refueling, and then the other pilot will get out and he'll rest for a while or sleep for a while, get to the next refueling, we both have to be in the seat and we swap. The next day, I am told, that manager actually had a sign out in front of his Walmart that said, our lounge chairs are B-2 tested. A B-2 pilot actually confirmed that to me. His call sign was Squirrel. I can't remember his real name. These 2 B-2s are coming back. And the second one is about to land after a 33-hour mission. And the tower cancels its landing clearance and tells him to go around. He says, wait a minute, why did you just cancel my landing clearance? And the tower tells him there's a coyote in the landing area of the runway. Now remember, these guys have been up flying this mission for 33 hours. And the pilot tells the tower, negative, I'm landing anyway. And sure enough, as the B-2 comes out of the clouds and comes into land, Mr. Wile E. Coyote realized that was not a safe place for him on the runway, and he actually skedaddles off. The airplanes come in, land, and the mission is over. They taxi back, and of course, ground crew and everybody is there to meet them. And they land fairly early in the morning, if I remember right. So the 4 pilots come in, they're getting all kinds of congratulations. The wing commander meets them, who I understand was Paul Tibbets III, the grandson of the same guy who dropped the bomb on Nagasaki. And out in front of them, they have this huge steak and egg breakfast and beer arranged for the 4 pilots when they land. So those are 2 stories, gentlemen, to help you understand why we do joint integrated fires, why we have persistent ISR, intelligence, surveillance, and reconnaissance around the world, why the United States can get so involved in these humanitarian things that happen around the world. And I could go on about stories, other stories, like the earthquake in Haiti, and how the drones are finding people and are mapping out the damage. The recent SEAL Team 6 mission that went down to Nigeria to rescue the one US citizen that was down there. Again, some British folks actually have a screenshot showing the two MC-130s with the two Ospreys leaving Mildenhall on their way down to Nigeria to go rescue this gentleman. And the two tankers that were involved, actually there was, I think, 3 tankers involved, going down and coming back. And the reason those tankers get involved is because we are trying to increase the range, increase payload, and stretch the endurance of airplanes that are flying humanitarian missions, intelligence missions, strike missions, or whatever, all around the world. The 4-star general who was the head of Air Mobility Command said in about 2 years ago at the Airlift Tanker Association convention that since 9/11, Air Force tankers, KC-10s, KC-135s from AMC, had transferred over 20 billion pounds of jet fuel into not only US receivers, but coalition receivers around the world. He said it wasn't just strike missions. Some of it was humanitarian missions. Some of it was intelligence missions. But these kinds of things go on every day behind the scenes. And like I said, the recent SEAL Team 6 mission down to Nigeria to rescue this one hostage is just one example. That's really all I had prepared today. I'm ready to take some questions. If you want more stories, my book is called Tanker Pilot Lessons from the Cockpit. It comes in all 4 formats, gentlemen, as you can see: hardback, softback, Kindle, and Audible. My website is right there, just markhasara.com. I'm on Facebook at markhasara.author. And if any of you ever want to get in touch with me, it's real easy. My email is mark@markhasara.com. Thank you again, gentlemen, for the opportunity to talk to you today. And I hope that you've learned something from these 2 stories and talking about how air power really does give the U.S. some distinct advantages to show compassion, to deal with some very nasty people, and to move airplanes, humanitarian equipment, and so forth all around the world. Let's go to questions here.
Yeah, thank you, Mark. Really a fantastic story. Fantastic. Would you be able to see the Q&A box?
Yeah, I've got it open right now. It's Gus is looking forward to reading your book. Both stories are compelling. Thank you from Gus. And let me go over here and look at
chat. Yeah, there's a
yeah,
chat.
I'm looking at the chat.
I think chat and Mr. Polinsky wrote something.
Fascinating presentation all around. Thank you. I appreciate that. Thank you very much.
Yeah.
Like I said, gentlemen, behind the scenes, these things are going on all the time. And Jim, you're at Seymour Johnson, you mentioned, in F4s. I'm sure you've sat in the F4 and have done the across the pond trip from Seymour to Germany or something like that during, what did they used to call it? Reforger, I think was the name of the,
Yes.
was the big exercise where all kinds of people from the States just dumped into Europe. And I remember doing those missions, and again, just some incredible things that the United States is able to do. But the mission, those missions to rescue those people from Flight 801 is something you'll never forget. I can still remember some of the phone conversations, with the State Department and talking to people in Guam and the National Transportation Safety Board Go team, head of the Go team saying, Mark, we got to be there 24 hours. Can you do it? Well, it's going to require refueling. How do you do it? And the Tanker Airlift Control Center is managing, I think, 500 missions a day since 9/11. And I'm sure it's probably more than that. But those are the kinds of things we're all doing. Anyway, an RC-130 pilot appreciates Mark Pestina. Mark, you and I probably have hooked up if you flew RC-135s. I was stationed at Kadena for 5 years, and you remember Mark getting up dark 30 for those 09 Echo missions, you know, coming in at like 2:30 in the morning.
Oh, yes. Oh, yes.
Weren't those crazy, you know?
Yeah. Yep.
Not near as crazy for us as it was for you guys. I mean, we refueled you and then off we went, and
Yeah.
you guys stayed for hours off the coast of a few places.
A few places. Yeah. Yeah. And as I said here, last month was my dad's 90th birthday. He's a former KC-97, KC-135 boom operator, and he appreciates your book. He's enjoying it. I can't wait to get it from him.
Oh, good. Good.
Yeah, you may recall I had it shipped to you, and you personalized it for his birthday. So we had a great 90th birthday. So the boomer loves it, and I can't wait. I can't wait to get it.
Yeah, if you get it back from him.
Yeah, if I get it back from him.
No, I was happy to do that for you, and I appreciate you doing that. And I offer that to any of you here that go out and buy my book. My email is part of the slides that you saw there. Just email me. I'll give you my address. And if you send me the book with another mailer inside with the right postage on it, mail it to me. I'll be more than happy to write a personal note in it and then send it back to you. And if you send it what's called printed media, it'll only cost you about $3 to send it to me, and $3 to have it come back to you. And I always put a personal note in the book, as Mark will attest to, and be happy to send it back to you. And just contact me at my email address, mark@markhasara.com. My email is my name. Any other questions?
Mark, this is Dave.
Yes, sir.
You're talking to an old tanker toad from that flew the old gal from 70 to 75 and later transitioned to E3s. And I can tell you there are times when we took the first E3s into Riyadh in the fall of 80, before Gulf 1 was even known as Gulf 1. And before the tanks were able to arrive in Riyadh, we were trying to keep the E3 aloft as long as possible. So I wonder if you could talk about some of the high altitude efficiency things that you could try to do to keep a jet in the air as long as possible before you have to refuel. I mean, we obviously had to be on station. We're operational for a period of time, and so what you could do to minimize control surface deflection, to keep the radar up and operating, to illuminate the area of interest and so forth was always a challenge before we got the tanks in there about 6 weeks later, and that was good to have them as support. So some of our 14 plus 15-hour missions on station were augmented by that, but otherwise, if you talk about how you could keep aloft as long as possible.
Yeah, sure. I you know what? I flew those ELF-1 missions. I flew those missions, Jerry, right after I got to Riyadh, about a month after the USS Stark got hit by those Exocet missiles. And I don't know if you were there. Remember how tense that was?
Well, we got right. We got there in September of 80, and that's before the tankers arrived. And it was a curious time to be over there, because when we landed, I mean, other people listening on us may not appreciate all this, but when we landed at the far end of the runway, as we were coming in over the city to land, were Russian blinder bombers, and we could see the tail flashes. But as we taxied by, they actually had they did not have the hammer and sickle, which is or the red star, which is great. But they're Iraqi blinder bombers that had been evacuated from Basra into Riyadh.
Yeah.
So some of the things you do see.
Yeah, are pretty strange. Okay. So what he's talking about is during the 80s, during the Iran-Iraq war, the Saudis were very worried about the Iranians coming south. And you have to remember, they had Tomcats. They had a lot of Russian equipment.
Yes.
Iraq had, like you mentioned, the bombers, okay? And ELF 1 was created to refuel the AWACS on these missions, all right? And Jerry, I actually talk about that in the book, because I talk about, remember the call sign was Sharp Echo. I went back in my logbook and because I'd always write down the receiver call signs too. And I got there about, I think it was 3 weeks after the USS Stark incident. So things were really tense. Anyway, it was called European Liaison Force, or ELF 1.
Right.
And tankers would rotate into Riyadh to refuel the AWACS to keep them up. And the other thing about this, which is really interesting, remember, we were using water wagons and A models at that time. Do you remember that?
Oh, sure. I know. I'm sort of curious because before you go on, we took off on the first mission ever coming out of there. And I can remember that the commanding general of Just Mag said, Captain or Lieutenant Colonel said, I want you to keep this thing aloft as long as possible. So,
Yeah. And without tanker support in your engines, that was tough.
right.
Because our rule of thumb was every 5 hours. The AWACS was going to require 80,000 pounds every 5 hours. And that's what we taught at our weapons school. Okay. You can just bet that the AWACS will need gas every 5 hours. And they haven't changed the engines on them yet. They've changed the engines on the RCs,
Right.
but not the AWACS. They still have the old
TF-33,
TF-33s. Yeah.
Yeah.
So we were taking off very heavy out of Riyadh in the old A models that burned water. So we were taking off about 160 fuel loads, and that was really heavy for an A model. Fortunately, that runway was very long and we could get up, but we would come up. Those missions were for the tanker were only, I think, 45 minutes, because your orbit, if I remember right, was up above Dahran.
Dahran, right.
Yeah, up above Dahran. And so we would go up there, just dump a bunch of gas into you guys and turn around and come home. And sometimes you needed 60,000, sometimes you needed 70,000, sometimes you only need 50,000 or 40,000. We just run around and come back home, you know? And so they were very short duration, but man, in the A models, we were rotating about 2,000 feet from the end of the runway.
No,
And so we were going low. And remember when you took off over the top of Riyadh, going to the north?
To the north, well, you had big sand dunes up to the
Yeah. Remember that?
Yeah.
And I'll tell you a funny story about that. We redeployed back to England, and we couldn't land before 8 o'clock in the morning in Fairford because of their quiet hours.
Right.
So we had to leave Riyadh like at 1 o'clock in the morning. It was really, really early. And again, I'm in one of these really noisy water wagon airplanes, and it was my turn to fly. I was a co-pilot. It was my turn to fly. And so I took off, and I looked over at my aircraft commander, a gal by the name of Leona, and I leveled off at about 500 feet across the top of the city with the water going.
Oh, geez.
That's
And
why
you
you
know-
woke us up in the Al Yamama Hotel.
Exactly. And I said, if I'm going to be up, you guys are going to be up. Okay. And I looked out in front of me and I saw the AIAA because it was on that flight path, not too far from that flight path. And I remember kicking in a little rudder and pointing right at the hotel. And finally, Leona looked over at me and she goes, "What are you doing?" And I said, "If we got to be up, they got to be up." And she's like, and she got all scared and everything like that. And we went right over the top of the AIAA with all the engines screaming in water. And the colonel, Elf 1 commander, called up laughing over the radio. Okay. And he says, "Thanks for the flyby." Okay. And so everybody in the cockpit, of course, is laughing and we're flying, and we get back to England and we land about, I don't know, 8:15 or something like that. And Major Dale Bible, who is the European Tanker Task Force DO, comes walking into the room shortly after we land and we're doing our paperwork and everything. And he looks at all of us. He says, "Okay, who did the takeoff?" All right. And I sheepishly raised my hand, and he goes, "Do you have any idea how many car alarms you set off in Riyadh tonight?" And I said, "No. Is it going to cause an international incident?" He goes, "I don't care." And he just started laughing and laughing. Apparently, it set off a lot of car alarms and so forth, my little stunt. So that's my one attempt at an international incident in a tanker, gentlemen. But now in the R model, it's completely different. We can take 180 fuel load, take off with 180 fuel load, be off the ground in like 6,000 to 7,000 feet. The CFM 56 engines are fabulous engines. I flew with them from 1991 until I left the cockpit in 2003. And I only had to shut down an engine twice.
Oh, that's amazing.
One time was because we broke an oil seal. And one time was because the main engine control computer card went bad in the middle of a flight after we had just taken off. We had 180,000 pounds of gas and the main engine control went bad. And one of our right engines was throttle bursting. So it's going like 65%, 92, 74, 96. I mean, it's just going like this. And the nose of the airplane's going back and forth like this. And we had to shut the engine down. But in order to land, we had to adjust our gross weight, as we called it in Okinawa. We had to dump 103,000 pounds of gas. Took us 20 minutes. 22 minutes to dump that gas out the back. Of course, we did it way off the island, up high where it atomized and so forth. But yeah, we had to get rid of 103,000 pounds of gas so that we could get down to our landing weight. And believe it or not, 103,000 pounds is my highest offload to any receiver, B-52. Back in the 80s, Jerry, that was flying from Castle to Darwin for Pitch Black, Operation Pitch Black, Exercise Pitch Black. So the R model has made a huge difference. It really has. 10,000 pounds an hour, you can bank on that. The A model burned 13 the first hour, 12 the second hour, 10 the third hour, and then we figured 10 after that on a 5-hour flight. It was a gas hog, and the R model engines have way more than paid for themselves.
Hey, Mark.
Yeah.
What did they ever do with the performance officer school at Castle? Because I went through that with SAC years and years before that. Did they keep that performance officer school alive?
No, they didn't. When AMC absorbed us, all the training went to Altus. Remember doing the whiff? With the B-52s, we used to do the 90-degree thing. Altus saw that and went, "You guys are out of your mind. You're not doing that anymore." So our syllabus changed when we went to AMC after the first Gulf War. So I know a lot of people benefited from that course you're talking about. That performance course was really good. You really understood takeoff data when you came home from that, and all the performance parameters. But the R model engines were fantastic. Matter of fact, in Okinawa, we had a takeoff procedure that we did with the F-15s on the inside runway and the tankers on the outside runway. And we'd get the green light from tower. We'd do this come out, and we could actually keep up with the F-15s as they were taking off and be at the end of the runway about the same time. We'd put the boom down and start refueling them right off almost the end of the runway, past 1,000 feet in a come out launch. And we used that several times. It was fantastic. Fantastic. The other version of that is the F-15s would take off on the inside runway, do a lap around the radar pattern, and then at 7 miles off the end of the runway, they'd give the tankers the green light, and we'd be off. And then they would form around us just as we were passing through 1,000 feet. Worked like a champ every time. But again, it was because of the R model engines, the CFM56 engines. They're fantastic engines. It really made the tanker into almost another airplane when we got those engines on it. And the story of those engines, gentlemen, is really fascinating. There's a book by, I think his name is Brian Rowe. It's called The Power to Fly. If you really want to read an interesting book, go find that book, The Power to Fly. He was a GE engine engineer, and he talks about the development of jet engines through the 50s, 60s, into the 80s. And a lot of people don't know, we almost did not get CFM56s. They were within 2 weeks of shutting down the entire program.
Well, because it's a European engine.
Actually, it's a US core and a European fan.
Oh, okay.
And that was the problem, was the core of the CFM56 is actually the core of the B1 engine, and it was classified. And that was the stumbling block. Pompidou and Nixon, when they had a meeting in Reykjavik, Pompidou had that on his agenda because they were trying to, GE and SNECMA were trying to marry up, and the State Department and Kissinger wouldn't let them because of the classification of the core of the engine. And they worked out a deal where they would the US would work the core in one area of the plant in Lyon and the other one in Cincinnati, I think. And they would marry up the two, the fan and the core, in a separate room. And then they would take them out onto the floor and do all the finishing touches on it. And that's how they got around the classification of the core. But the reason was because the core was a part of the B1. And since the B1 was going to be a SAC asset, they had to classify it.
Oh, okay.
Yeah, it's really a fascinating story of how this happened. And if you Google CFM56, the write-up in Wikipedia actually explains all this. It's really, it should be a great paper for an MBA student to show all the marketing you have to do, the engineering, and where the money goes, and what happens when you can't get certain agreements to work together. And of course, finally, Nixon comes home and goes, "So what's up with this?" And they work it all out. That they'll work on the core in a particular room, in a walled off room, and mate the engine, and then you'll be able to work on all the stuff. And that's how they got around it. But they didn't have any customers. And finally, the French said, "Let's put them on our tankers." So the French tankers were the first ones to get them. But Boeing had put 4 of the CFM56s, Jerry, on a 707 airframe. And we're going to market it as a new 707 with these fantastic engines. And the performance was phenomenal. And Boeing knew it. But Boeing was trying to sell the 75 and the 76. And they said, "We're not re-engineering the 707. And so Boeing just kind of poo-pooed it and shoot them out the door.
Right. Yeah.
And like I said, the French put them on their tankers, and then Delta, United, and Flying Tiger Airline choked down their pride and says, "Okay, well, let's put them on our stretch DC-8s." And the rest is history. I mean, the DC-8 performance with the CFM56s was just fabulous. And that's when the Air Force said, well, if you get them on these airliners, then let's go ahead and look at putting them on the tankers. And they had the new upgraded JT9Ds, you know, and Pratt & Whitney was going, you know, CFM, they don't make, you know, military engines, we do. And CFM won.
Mark, this has been Dave Hartman here. He's an Air Force pilot, retired, sitting
Yeah.
here with me. But I had a question for you. I'm curious,
Sure.
on the retirement business card, does it say retired but still passing gas?
I tell all my wife's friends that I'm still passing gas, Dave.
Very good.
I introduce myself to my wife's friends. My name is Mark and I pass gas for a living. But you know what, Dave? People don't understand the amount of gas we're talking about. I think I told you guys.
And the fact that gas weighs 6.5 pounds per
Yeah.
gallon.
Yeah.
And what all that means, we're talking about pounds of fuel. Other people
Yeah.
talk about gallons. So if you talk about taking on 185,000 or 188,000 pounds of fuel, what does in terms of gallons, in terms of on a 135? That's a lot of gas.
So let me give you an idea. Okay. I actually got asked this question. Here's the story. We're coming into Baghdad and we're flying. This is the invasion of 2003. We're flying missions like crazy. We are maxed out on tankers. We can only do 265 sorties a day, and we're right about 17 million pounds offload. We don't have any more tankers. We told the Master Air Attack Plan cell, this is all you have. You have to back the air campaign into the gas. Never done before. Never done before. All right. And of course, all the fighter and bomber guys are going, this is insane, Sluggo. We've never done this before. We've never done this before. I said, you don't have a choice. He says, get more tankers. We couldn't, because the terrorist alert level went up in the States, and they had to have 120 tankers on alert. And over in the Pacific, Kim Jong-un's dad thought it, you know, well, they're busy in Iraq. Now's a good time to start launching missiles. So 26 tankers went that way. So we were out of tankers. We didn't have any more.
Wow.
And 2 days before they made the Thunder Run into Baghdad, we did 17.5 million pounds. We flew every crew twice a day. If the war had gone on beyond 30 days, we were going to have to sit down about a third of the tanker force because of flying hours, crew duty month.
Such a flying time.
Yeah, they're out of flying time. Okay. And we'd have to sit them down for like 48 hours. And I remember showing General Mosley this, and he goes, this will be done before that. I said, okay. And sure enough, man, we got to the end of it all, 26 days. And anyway, right before we went to Baghdad, a major in the Pentagon calls me and says, hey, my general wants to know how much gas we've offloaded so I can put it on the slides. And I'm like going, who are you? He says, well, I'm this major working for this general. I'm like, and I literally said to him, your general's not my general. And I hung up on him. Okay. And about 5 minutes later, I see the same number and I pick it up and it's the same major. He says, can you help me out? And I said, no, I can't. Bye. And I hung him up on him again, because we were right in the middle of trying to save Jessica Lynch. That mission was going down while he was calling.
Oh.
So we were really busy. Okay. And he called a third time. And finally, I had pity on the man. And I said, look, we're right in the middle of something, okay? You're going to see it on the news probably in the next 20 minutes. And you'll understand why I'm hanging up on you, okay? But give me 30 minutes and call me back and let's talk, okay? Because he was saying, can you please help me out? My general will not let me put this slide deck together unless I said, how did you get this number? You know, how did you get I happen to be the chief of the air refueling control team. How did he find that number? I don't know. I said, call me back in 30 minutes. And he says, you will pick up the phone, right? And I thought about that for just 1 nanosecond, maybe. and I hung up the phone. And like I said, we were right in the middle of saving Jessica Lynch. So that went down and we got her out, and that was a fantastic mission. And he calls back and he says, okay. And I said, okay, what is it you want? He says, I need to know the total offload out of Air Force tankers. And I said, okay, give me 30 minutes and let me find that, because we're just wrapping up some things here, you know. And he says on the phone, he goes like, hey, did you hear they just rescued Jessica Lynch? And I'm going, you think? I'm right here watching it. Okay. You know, anyway. So he calls back, and General Mike Mosley had just bought a Ford F-150 truck. He'd only had it for about 6 months. So we took the amount of gas we'd offloaded and figured out the miles per gallon of his truck. And here's what we came up with. Transferred 417,133,000 pounds of gas. That's how much we'd offloaded. That would allow Mosley to make 2,685 round trips to the moon, or 7 round trips to the sun in a Ford F-150 truck.
Oh, man.
Okay.
Pretty dramatic.
Yeah. And so he called back and I says, I've got some great stuff for you. And he goes, okay, give it to me. And I said, 417,133,000 pounds. He goes, oh man, that's a great number. That's a great number. I said, I'm not done yet. Tell everybody that would allow Mosley in his brand new Ford F-150 truck to make 2,685 round trips to the moon, or 7 round trips to the sun. He goes, that's great. That's great. He puts it in his brief. Okay. Apparently that was too good, because the Pentagon public affairs guys got a hold of that number. And 2 days later, Mosley comes, the next day, Mosley comes up to me and says, Sluggo, what the hell did you do to my truck? And I went, oh. And I sheepishly go, I don't know what you're talking about, sir. I don't know what you're talking about. He goes, oh, yes, you do. Why is my truck in all the newspapers back home? And I started laughing. And I got thrown under the bus by all my buds around me. He did it. I saw him on the phone. I saw him talking to the Pentagon, you know. And of course, you know, he goes, Pentagon called? And I says, well, this major working for this general, he says, you let a major tell a deployed lieutenant commander, a deployed lieutenant colonel what to do? You know, I mean, he's just sticking the knife in me like crazy. And I said, well, yeah, kind of. And then I told him, I said, here's what we gave him. He laughed like crazy. He thought that was great. Sir, your truck can make 2,685 round trips to the moon, or 7 round trips to the sun with the amount of gas we just offloaded. Okay.
These great stories, Mark. Great stories.
180,000 pounds was our typical war load. That's 27,395 gallons. A typical American family uses 1,010 gallons a year. So a typical American family can drive their car for 27 years on the amount of gas I take off on one mission. I'm telling you guys, Leonardo DiCaprio and Al Gore and their eco footprint, they're amateurs compared to mine.
That's passing gas big time.
Yeah, they're amateurs compared to mine. All right, we got one last question. Oh, outstanding. Randall, thanks. Gentlemen, it's been a pleasure to be with you today and sit and talk about some fun stuff. I'm sorry, I left the Air Force, went to work for Rockwell Collins designing cockpits for airplanes. I kid everybody, I went as far in engineering as my political science degree would allow, and but really enjoyed seeing the engineering side of, you know, what's in a multifunction display and what's an Ethernet and how do you wire up a cockpit and so forth. So I became an amateur systems engineer for quite a while I was at Rockwell. So I appreciate everything that you gentlemen do and continue to do for our country and for the people here on the great planet Earth. Sluggo signing off.
Thank you so much. This is really fantastic. Yeah, we'll look for more opportunities working with you for more article presentation.